I got a signal so I can start. So good morning, welcome to Primusday 2025. My name is Ladislav Krištoufek, I'm Vice Rector for Research here at Charles University, but we will start with the most important person, of course, and there will be the welcome word from the Rector, Professor Milena Králíčková, so please take your spot.
Dear colleagues, good morning. It's my great pleasure to welcome you at the Patriotic Hall of Charles University and to welcome you for another Primus Day, which we held here traditionally. What is the Primus Day about? For me, and I hope that for a lot of you as well, this day is about building community. I'm so happy to see that plenty of you really arrived to Patriotic Hall, and of course I'm greeting also those who are online. But being here means that we are creating Primus family community, and this is extremely important. Your voice of young research stars, people who are interested in science and who are bringing new energy and quality to science at Charles University really means a lot. So for me, Primus Day is about building community, and I would like to thank those of you, all of you who are here. And for those of you who are online, I truly hope and believe that next time you are going to be here and help us to create this Primus community at Charles University. And the second thing, and actually that's for all of you, Primus Day, I believe, is also about the feedback. Charles University for many years is already trying to focus on support of young researchers. We are trying to focus on bringing the talents to Charles University to do the best science in Czech Republic, to do the best science worldwide, to do the science that really makes impact, to do the science that really moves us all forward. So we want your feedback. We want to see how much you feel and see that this effort really brings new quality and new outcomes to your faculties. Charles University is really large, 17 faculties. Most probably all of you here are from really different faculties. So the third, and for me, one of the most important things is that Primus Days also contribute to interdisciplinary research. I hope that you will meet each other here today, that you will exchange the ideas, that you will give us feedback, and that you will help us to create really a Charles University academic family that is going to do great science, bring excellent education, and really change our community in Czech Republic. I would like to thank you once more. I wish you to have really good and pleasant and efficient day. And last thing, I would like to thank all those people from Rectorate that contributed to really creating this Primus Day, from the Department of Science and Research, from other departments of Rectorate. Thank you very much. Enjoy the day, and I truly hope to meet you either here at Rectorate or faculties in future. Thank you so much.
Thank you very much, Madam Rectress. And now we will continue with the program. We will start with my presentation about what Primus actually is. Of course, you probably know, but I will try to put my take on it in a way. Apparently, it's not 13th January, but March. That's my mistake. And it's best to point to your own mistake right at the very beginning. But anyway, so what is Primus? This works, right? Okay, right. So first, a little bit of history. Primus started in 2017 as a program to support the foundation of new research teams, majorly by PIs with extensive international experience. It might seem that it's just a few years back, but of course back then it was quite revolutionary. It still kind of is in the Czech environment. And also the fact that this extensive international experience was kind of assumed back then was still quite new to the environment. And in the first few years, this focus on international people was there, but it wasn't that easy to actually attract them. Now, and by international, I don't necessarily mean foreigners, I of course mean also people returning back to the Czech Republic, but also people from abroad in general. And it's become more and more an international program, I would say, since 21, at least from how I see it. So this way, it had some stumbling steps at the very beginning, but I think from 20, it really works in the international idea that it was supposed to. It's meant for people up to 8 years after finishing their PhD, so in this kind of a postdoc kind of a phase of the career. And the main aim is to attract returning researchers or new international ones, as I said. And the motivation, of course, is to fight inbreeding and support brain circulation. We are not draining, we're circulating, as always, of course. So that's the basic setting, which seems quite simple, but, as I said, still kind of revolutionary. How it compares to other programs that we have, I will get to some more details about Primus, of course, later, but how it compares to other programs that we have at Charles University, so, and well, with similar focus on young researchers. So we have GAUK, the grant agency of Charles University, which is meant for PhD students mainly. Master students can also apply, but now the focus is more and more, and it has always been more on the PhD students, but with the PhD reform, the focus is going to be even more clear. Then we have the UNCE. I use the Czech pronunciation because it sounds weird, so why not? It's the University Centers of Excellence. That's for young researchers under leadership of senior researchers, so already supporting an existing team or existing senior structure that is being filled by junior researchers as well, and to build this team more and more. So it's not for new teams, it's mostly to support already existing excellence. And then we have SVV, or SVV in Czech, which is specific higher education institutions research, which is a further support for PhD students. There have been some changes to it practically every year, because now we have like 6th last year of SVV or something. So this seems that 2025 might be the last year, but we'll see. Anyway, it's quite connected with GAUK because it comes from the same source, from the Ministry of Education, but the SVV is more directed to the existing teams and to support the infrastructure at faculties, but mostly it should be directed to PhD students. And again, with the PhD reform, this has been changed, and it will be changing quite a bit as well. So as you see, this is mostly about PhD students. The Centers of Excellence have these young researchers were there, but it's also a lot, well, it's usually for more senior than postdoc researchers. So Primus was founded as kind of a filling of this gap, and mostly motivated by the fact that back then, in 2017 when it started, but before, of course, the postdoc market or postdoc situation in Czech Republic was practically non-existent. Right? So we knew that there are some young researchers or young assistant professors, but abroad they have some postdocs, but we don't really know what it is, we don't know the word, there's no Czech version for it, so how to work with that. So this was really to try to actually make it existent, to work with it, and to support postdocs and become part of the postdoc market, of the European one or global one, but mostly maybe the European one, but to really start this postdoc category as an actual international one, how it exists abroad. So again, revolutionary in a way, and of course from the international perspective, not that revolutionary when you have postdoc market standardly, but here it was mostly about creating the postdoc market and supporting it. What makes it special from what makes Primus special from the perspective of its structure? First, the projects are being selected with the ERC logic in mind. So mostly frontier research, bold, maybe even daring ideas, possibly leading to breakthrough in the field. So we are willing to take the risk. Of course, now the ERC mentality is changing a little bit. The focus is not so much on the frontier research. The word is not being used that much. Now the breakthrough is used more. What's the difference? Doesn't matter, right? So the idea is that it's not supposed to be something mainstream in a way that, okay, I've been doing this for 5 years, so I will just continue doing that. And we'll see what happens. No, that's not what it is. It's supposed to be something potentially or possibly breakthrough that will really contribute to the field, but it's not a certain thing. So that's the risk. Of course, we talk about risk a lot now at the European level, and the discussion about the research environment and innovations is now a little bit complicated, to put it mildly. But the riskiness part there, even though, again, it's not in the ERC documents now, but the idea is still there. Not the business as usual, but really trying something new, something contributive, and something uncertain. So that's the idea or spirit of Primus that takes after ERC, because in a way, or mostly, Primus was constructed as a pre-step to ERC application. Of course, it's not a necessity, but the idea is there. Okay? And that idea gets projected into the structure of Primus as well. And that connects to the second bullet, which is that the second and third, that the project proposals are relatively, not really structured. So you don't need to fill, 10 different, rows or some specific fields. It's mostly about present yourself, present what you want to do, and try to persuade us that it makes sense, which is quite different from what we're often used to, where you need to follow the documentation step by step and to have it there to have at least a chance. The third bullet is very important. The budgetary restrictions are practically non-existent. So it's mostly, here's the money, do something with it. We trust you, see you in 4 years, in a way. Okay, I'm simplifying a bit, but, compared to standard programs and standard grant and project structures, this is very, very different. Of course, by budgetary restrictions, I mean the structure, not the money. Of course, the money is restricted, and that's up to 4 million Czech crowns annually. I'm just checking in the back that didn't change, right, for this year. I think, yeah, it's still 4 million Czech crowns. And the project is for 4 years. There's been some evolution in this. We used to have 3 years plus 2 years top up, let's put it like that. But now we have 4 years project by default. So as you see, when you put it together, and for people from Czechia or knowing the Czech system, Primus is really not a big gotcha kind of thing. Okay, so it's not the big Czech Science Foundation project. It really is structured very differently. But of course, it doesn't mean that if you were successful in gotcha that you cannot be successful in Primus. Of course you can, but the way you write the project and how it's structured is very, very different. Now, about the selection process. So important thing is that you need to get in touch with the faculty where you would like to realize the project. Because the faculty commits to co-financing, either 50% or 25%. So the faculty needs to be okay with that and needs to be willing to provide this co-financing. So it's better to get in touch, or you should get in touch with them, because when you are submitting the proposal, there is a tick whether the dean confirms that or not, and in the end they really need to confirm that. And we did have several occasions where this was problematic. We were able to sort it out somehow, but it's certainly good to get in touch and be sure that the topic, maybe yourself or the team, is fitting into the faculty strategy, and you're not forcing yourselves on them, of course. So, good idea or a necessity to get in touch with the faculty. We have 3 categories or blocks. The standard ones pretty much, so we have the medical one, the sciences or natural sciences, and then we have social sciences and humanities. The selection committees are formed by, not exclusively, but majorly by externally experienced researchers, and there are some, or if needed, if the specific field is not covered, then we use additional external reviewers as as well, but it's usually one rapporteur and two reviewers, so it's 3 people in total, most of the time, sometimes more. And the major criteria are likelihood of establishing a new team or lab leading to successful prestigious international grant or project application, scientific excellence, whatever it means, of course, and contribution to the faculty and university and international experience. Of course, in these 3 panels, the expectations are somehow different, or the standards might be different. So for some, the international experience is more important, or some kind of a threshold that needs to be met for the project to be successful, or are taken as kind of a baseline. For some, the focus might be a little bit different, but mostly the idea is there a chance that this project will lead to establishing of this new team, and is there a chance that it will lead in these 3-4 years to a successful application for some reasonable European project? Of course, that's not easy to say 3 years in advance whether this will be successful or not, of course, but it seems that it works. Every year we get between 40 to 50 proposals. The success rate is around 40%, which is quite high, or it might seem quite high. But the important thing is, the first bullet I had in the previous slide, is that there needs to be a confirmation by the faculty, so there already is some kind of a pre-selection at the very beginning by the faculty. Either on the theme or the topic, or maybe the possibility to actually co-finance the project, or whether it fits into the strategy of the faculty with respect to the fields that they're interested in and that they want to develop. So it's not, it's not an easy thing to get it. It might seem that 40% is super high, of course, when, all the other programs have like 10, 15%. So here it's mostly about the pre-selection, not mostly, but the pre-selection plays an important role. In the end, the quality of the proposals is usually very high, I would say, because I sit at all the meetings, or I try to sit at all the meetings. Of course, I don't intervene, I just watch. I intervene only when something wrong happens, which doesn't, so that's good. And I see that, there are really just few projects like, 2 or 3 in the bunch that are not good, but the others are usually very good quality, so it's not easy to select the best one. So there is certainly a good selection there. The success rate varies a bit across the panels. The lowest success rate is in the medical panel, which is something that's been there since the beginning, pretty much. But I think it's getting better, at least the 3 years, 2, 3 probably, 3 years that I've seen as a vice rector. The quality is getting better in the medical field. So it's not necessarily that in the medical field the panel or the reviewers would be stricter. It's mostly that the very best there are just few. The others are good, but the chance of establishing a new team is not usually seen there. So that's something to think about maybe. So it's not necessarily about that you would have a lower chance. Of course, you would have a lower chance if it was rolling dice, but it's not rolling dice, right? So if the project in medicine that you submit is very, very good, there is very high chance that you will get it. Now, the question might be, does it work, or does it do what it's supposed to? One indicator, of course, it's not necessarily the only thing that's important, but the conversion rate, let's put it like that, is quite high. So around 75% of the Charles University ERC holders are also previous Primus holders, and around 50% of Charles University ERC CZ holders are previous Primus holders. So that's quite good. Of course, it depends. If you're you can look at the probabilities from the other side as well, of course. So it depends how you want to tell the story in a way. But you can see, because then the conversion rate is, of course, not everyone that gets Primus gets ERC, right? So that might be a bit trickier, but the success rate from the other side is certainly higher than the average success rate that we have across Europe. So pouring money at people with a promise seems to work, which is good. And if it doesn't work, you can always become vice rector, because I'm Primus holder as well, or I was, not now of course, but I'm a 2019 cohort, I think, if I remember. But I will stop telling this joke, next year or something. So, but I can't help myself. So I was supposed to start writing the proposal when I became vice rector. So, maybe next time. But I didn't convert anyway. So that's the basics. What I also want to say, apart from the schedule that's ahead of us, I will check the time. Yeah. Is that the Primus program is really, even though it's based on, or it's built on relatively simple idea, which I think is trust. So trust the people, trust the researchers, give them money, see what happens. That's important. We don't see that much. We talk about trust a lot, but then we have all these indicators and KPIs and whatever, because we don't trust people, right? We want to have something objective. So here we're trying to do something different. We really try to believe in people, trust them, give them money, see what happens. And of course, at the beginning, you need to do the selection process where you kind of try to figure out whether you can actually trust the people that they will deliver. But this is very new, and it's not easy. It's not easy to do it, actually. Other universities are trying to do this as well. They are not really being that successful. Academy of Sciences also has some program that is kind of parallel to Primus, which is also not that successful, to be on, well, at least from the statistics. So it seems as a simple idea, but having a program that is built on trust, that gets quite a lot of money, and has quite at least a medium-term time frame where you see the results, it's not easy to keep it. So I'm really glad that we've been able to keep it, and we will be able to keep it, and that Primus has really developed into a standard that we have at Charles University, and there is not really a question whether we should have it or not. There is more a question whether we should put more money in it. We also built or rebuilt, let's say, restructured the Donatio program that used to be as kind of a premium to more senior researchers for what they've done already. We transformed it into like Primus for more senior people, in a way. By senior I mean like more than 8 years after PhD, so not like actually senior. And we are trying to expand it more. Try to get some chairs connected to that. So we really think that the way Primus is built works, and we want to develop it more. We are trying to develop the idea into other programs as well. So hopefully they will be as successful as Primus is. So for today, the structure is the following. So first we will have a section where the current ERC grant investigators from Charles University will present. This will be Michal Smetana and Zuzana Musilová. Then we will have a talk by Zdeněk Strakoš about why to submit at Charles and about the spirit of ERC as well, I would believe. Then we will have 15 minutes coffee break. After that, we will have 3 presentations of the current Primus investigators. We'll have Jan Kulvajt, Martin Kozák, and Ján Antolík. And after that, we will finish up with the poster session walking lunch, well, let's put it like that, a networking lunch, which will run from 1:45 till 3:30. So thank you very much for coming. Also hello to people online, which I didn't say. So hope you'll enjoy today, and we will probably move to the section. We are 3 minutes ahead, but I think that's fine. So I will ask Michal Smetana to take floor. Enjoy.
Right. Hi everyone, pleasure to be here. Thank you so much for the invitation. I was asked to try to put together a short presentation that will basically show you the way of how I got to Primus and from Primus to ERC. It was supposed to be 30 minutes, but I will try to rush it a little bit so that we have a little bit more time for some questions in case you have some. Some of you have already approached me before. It was quite a nice conversation, so maybe there will be something that you would like to ask me that is not really covered in the presentation. So let me start briefly with the idea for a Primus presentation, and I must say from the start that we, and by we I mean myself and my team, we actually from the start have it like a way of establishing some kind of a group that will eventually try to propose ERC. So the idea was there from the very beginning, so I'm glad to hear that this is actually the broader philosophy behind these projects. But it kind of brought us to a couple of dilemmas that we had from the start of how to structure the presentation, how to frame it, and maybe my experience is not completely representative, and it's actually possible that there is like the people who are evaluating the project have different ideas than I had. But I want to give you some glance of what we struggled with and how we did it in the end, right? So the first dilemma we encountered was to what extent we should propose the project as a sort of like a new lab, which would then eventually develop some research ideas and put it in place, and to what extent it was supposed to be like a cohesive, proper research project, with clear research questions, with some clear hypotheses that we are testing, research strategy. I don't know if the application is still the same as it was at the time when I was applying, but at the time I kind of felt it somehow in the middle because, obviously the proposal is very short, right? So it kind of was more aligned with the idea that this should be like kind of like a formulation of a new lab team kind of a thing. But at the same time, I mean, there were actually fields that actually ask about our research strategy that was supposed to be quite specific. So that was the one dilemma, and soon I will tell you how we solved it, and hopefully successfully. Obviously, we also struggled with the idea how big the team should be, right? I mean, the money that we would be receiving through Primus is actually quite substantial, but we were not sure to what extent this should be a large team, to what extent this should be a small one. So that's another one. How senior the people should be, right? If I should actually include more senior people than I am, or I should be the one that is the most senior in the team. We also struggled, or I struggled when I was putting it together with this ERC idea, to what extent this can be a continuity of what I've been doing up until then, and to what extent I should actually formulate something completely new, right? This is super important for the ERC grants. I mean, this was highlighted to me like so many times that I should never show that this is like a mere continuity of what I did before. It should be like something that should advance my work. And I wasn't sure how to apply this in the context of Primus. Interdisciplinarity was another key theme that I discussed with my team, so to kind of top up the game. The outputs, I mean, I feel from what Ladislav Krištoufek said before, and from others at the rectorate, are generally claiming that the philosophy of Primus is closer to ERC in the sense of that not to put too many indicators, but at the same time, we always have this risk-averse strategy to at least formulate some ideas about what outputs can be there, because you are always worried that there will be one of the evaluators will have this more gotcha mentality and will look for some kind of very specific indicators. And yeah, the last point I already mentioned, that we really wanted to formulate it as something that would be like an in-between stage going towards the ERC. So this is how we eventually solved it. I mean, this is the project that became funded. By the way, it was my second attempt. The first one was rejected, so I only got it for the second time. I think that the name was the same, but we kind of tried to solve the dilemmas that I just outlined in a slightly different way, and then it somehow clicked on the second attempt. As you can see, the project was actually formulated as a lab. I mean, that was the idea at the time. I mean, we formulated as a new group, which is interdisciplinary, that is composed of political scientists, of social psychologists, of one behavioral economist, and that this should be like a, let's say, group of people working towards developing different research ideas. At the same time, we did formulate in the end some very specific ideas about how we want to do our research. So how we solved the dilemma was to formulate like 4 broader, or here are 5, I eventually added one more, broader research ideas, connected with some examples of how the studies that we want to conduct look like. So, I mean, we kind of outline like a more general plan of how we, in my case, I do survey experiments, so we kind of showed in the proposal how such a survey experiment look like, how many people we usually recruit for such an experiment, how many such experiments we need to do in terms of one study, what kind of samples we use, what countries we want to focus on. We had a very strong cross-national focus to show that we are really going beyond just like surveying just Czech Republic or only United States, which is the most popular country in our field, but try to compare findings from different countries, and showed some kind of like a basic idea about the statistical method that we use in order to analyze data. So that was kind of like a middle way of, showing it, okay, this is like a core team with some research ideas, and then also show that we have some feasible plan of how to conduct individual studies. Frankly, I mean, eventually the whole project brought us to very different directions than we expected. When we were struggling or how to solve this dilemma about the outputs, eventually we did formulate like some kind of like a preliminary plan. I didn't formulate it in the sense that we 100% commit to publishing these articles, but more like okay, I expect that if we actually get funded and we will work on this, we will eventually get to 4 peer-reviewed articles, 1 for each of these areas that I outlined in the project proposals. The 3 papers should be accepted by the time of the project is concluded. I said accepted because you cannot really influence when the paper will eventually be published, but I saw that accepted is like a sufficient stage of where we can get during these 4 years, and that 1 paper at least will be in the advanced stage of peer review process at that time. So that was the general idea. As you can see, we eventually actually delivered more than we promised, but frankly, I mean, just like being very calm and like not being super stressed about how many outputs I'm really committed to do, that actually help us to take some risks, and eventually we published even more than we promised. We did promise 1 monograph. Sometimes people ask me whether this should be promised in the context of Primus. Honestly, I don't know. In social sciences, this kind of makes sense if you have a broad research agenda for a couple of years, then to put everything together into a single monograph. I haven't published it yet. I have a preliminary contract from a publisher to write it, but I'm super delayed, so I'll definitely not be able to publish it by the end of the Primus project. But yeah, it's somewhere in the working. We did put a lot of effort into promoting the project, so we set up a Twitter account at the time, now X, and then a website that we tried to promote. It actually brought us quite some attention and some cooperation from abroad, from people who do use experimental methods to study political science, so that was quite a good achievement. We did have a PhD student who was helping us to promote the project in addition to some research work, so that was very helpful. And obviously there was one output that we promised like in a, I would say, very committing way in the original proposal, and that was to propose an ERC project sometime during the Primus project execution. At the time we promised some VR experiments. At the end we changed it to something else, but the idea that we should continue with the same kind of research agenda in the ERC context was there, and eventually brought me to the ERC starting grant application, which is this one. I somehow waited until the last moment, and it was the last year when I was still eligible to propose an ERC starting grant. I'm not sure if this is the best strategy, frankly. I mean, but the truth is that before I didn't really feel that I have a strong idea to propose for ERC. I was playing with the idea already the year before, but I just wasn't sure what to propose. So it took me a while, and then maybe the time pressure of having the last year of being eligible to submit ERC kind of hit me, and eventually I put it together. I submitted the application in the 2nd year of the Primus project, and I just started it this year. So this is the 4th year of my Primus project, so this was kind of well aligned, and I mean with the whole duration of the Primus. and there is like a small overlap now of 1 year, which is not really such a big problem, because in Primus we kind of already did most of the work we wanted, but yeah, it just went well. The project is called the Micro Foundations Collective Defense. The idea behind it is that we study the role of public opinion in collective defense commitments, again through survey experiments. The collective defense is an area of international security, which is some kind of a continuity of what we did in the Primus project. This is where we continue with my team. At the same time, the collective defense itself is like a new empirical area for me. So when I was proposing ERC, I was able to show that this is not just a mere continuation, but I'm kind of trying to explore some new territory, some new area, which I didn't really study before. Eventually, I settled for a small team, even smaller than the Primus project. I have 3 postdocs, and one of them is not even like fully committed to the project, so it's like an international collaborator. I have 1 PhD student that we now selected through open call procedure. Yeah, if anyone would be trying to do that, I have many tips of do's and don'ts, but I'm super happy with the result. We have an amazing PhD student who studied MA at Oxford, and yeah, I mean, she's much better methodologically than I am, and I'm super happy that we have her on my team, so she's starting very soon, and yeah, she's quite amazing. We also have 1 project administrator that actually does a lot of work, because the key idea I had behind this project, and in many other projects that I'm running currently, is that the researchers shouldn't do the admin work, and we have someone who's actually really willing to do the hard work for the researchers, and is always there to do maximum she can, so that we don't have to fill the forms, and she does it. Very briefly, because I believe this is not so relevant to you, but I was asked to at least like briefly show what we are working on. Basically, I formulated like a new, relatively simple theoretical model, which kind of tried to show how attitudes towards collective defense form on the level of individuals in different societies, how that eventually becomes public opinion, forms through different social cues, from politicians, from peers, from media, from journalists, and then how the public opinion, when it's formed on collective defense, influences the elite decision makers. So that was another kind of like a step up in our game, so that we don't only survey public samples, but we now do a lot of experiments on samples of politicians in different countries. For example, we do experiments in German or the British Parliament, where we, rather than working with ordinary people, we just work with politicians who are filling out our surveys, and we try to provide our field with some findings which are slightly more closer to the practice, which are a little bit more relevant, because we actually are getting some insights from policymakers themselves. Another major methodological contribution that we included in the ERC project, and that was evaluated quite highly, was that rather than just using these surveys where you read the text and then fill in the questionnaire and that's it, we are now playing a lot with different mixed media content. So we are now, for example, generating some scenarios partially using AI, like to provide the respondents with convincing videos that are a little bit more realistic, and then kind of brings them a little bit more to the situation that they are evaluating. And we are now testing to what extent we are able to get some, let's say, stronger emotional reactions from these respondents, and to get them more attentive to the surveys that we are fielding. Again, this was something that was quite appreciated by the panel and by the reviewers. Another thing that was appreciated was that we have a very wide cross-national outreach. We do our surveys in many different countries. Originally, we actually went even beyond these NATO countries that I have on the map. That was found to be a little bit more too ambitious. I still don't think so, but anyway, after some feedback, we kind of scaled it down, and this is, let's say, the plan that we are working on at the moment, fielding these different cross-national surveys among both elites and the public in different countries. This is a figure from the proposal itself, so I'm a person that is usually like very structured, so I kind of try to suggest of how the whole structure of the project will be there. I did use the work package structure despite the fact that it's not really required by the ERC, unlike in some other Horizon projects, but it kind of helped me to think more in a more systematic way about what I want to do in my project, and I also kind of try to outline what each person in the project would be working on in this duration. Obviously, this table is connected with a description that clearly shows who's working on what and what role is there for each member of the team with respect to each of these work packages, which as work packages are quite aligned with the 3 models that I have in my theoretical framework. Yeah, this is the budget that I was working with. Again, I mean, you will get many recommendations when it comes to budgetary aspects of your project. I was warned that our strategy, which kind of cuts a little bit the personal costs and puts a lot of money towards survey experiments, was slightly risky, because it's unusual. Eventually I did it because, again, like this is what we do. I mean, the conducting survey experiments is very expensive, especially if you want to work with large samples in multiple countries. So we did put a lot of money there and just like did a lot of work explaining and justifying both the reason for these costs and also the costs themselves, right? So before we obviously did a number of experiments in the Primus project, so we had some kind of idea of how to calculate the cost per single survey or per single survey experiment. So we try to provide in the ERC like quite a detailed calculation and explanation of what these costs actually entail and why they are that high. This is something I wrote when I was trying to work out the whole journey of how I got to ERC. Basically, I don't expect you to read all of this right now, but basically the whole story is that, let's say, it took 1 year to get to the point when I submitted the project. Basically, like around September 2022, I started like, formulating the first idea, getting the first feedbacks from my colleagues. At that time, I was still thinking about like 3 different directions, quite different ones, and eventually I settled for one sometime late in 2022. And the whole story with different workshops and training sessions and feedback sessions with people and mock interviews and stuff, it basically took up until October 2023 to get the grant submitted. This is just for you to get the idea of how long the procedure can be. I mean, the project actually was not that long when it comes to writing. I was surprised at the time. I always kind of, I had some experience from Horizon projects. I expected it to be much more complex and much more administratively difficult. It really wasn't. What was difficult and different was that I actually had to rewrite the project so many times that the last version that I submitted in October was very, very far from the original idea. And I got so much critical feedback, basically saying, okay, this is not feasible, this doesn't work, I don't understand what you mean, this is not ambitious enough, this is too ambitious. So after all of these comments, I actually had to rewrite basically every single sentence in the proposal, and that took a lot of time. So it wasn't the extent of the project itself, in a way, the length of the project proposal is basically like a gotcha grant, so it shouldn't be anything that demanding, but the overall ambition and the pressure to like really clarify every single aspect of your proposal and put there stuff that you didn't think that is necessary there was there the whole time, and that kind of brought me to the eventual result. I would say that the most important part was written during the summer, like these 2 months that I really wrote the B1 and B2 parts, and that was almost the done project in September, still kind of revised, but in summer that was the time for me to do that. So this is just very briefly from the an excerpt from the evaluation report. I got 8 reviews. Some of them were really short, like half page, like very, very general. Some of them were quite long. There was the longest one, 1.5 pages. So that was quite complex. The panel gave me also some comments, like 1 page. Generally, they did focus a lot on the project itself, but truth to be told, they did focus a lot on my CV, despite the fact that, you know, you will hear a lot that the CV is becoming like secondary these days, and I'm sure that officially it is, but there were so many comments related to my CV that obviously the reviewers found it important. I'm not necessarily saying the panel took them into account in the same way, but there were many like that. After I get this first evaluation report, I was invited to do the interview, which once again was quite a new experience for me. I had like 1 month to properly prepare for the interview. Basically, I spent the whole month preparing for it, like 1 hour daily. So when I was like trying to revise my presentation and to, you know, sometimes get some feedbacks from colleagues, I need to stress that each panel has a very different format. I'm sure that you have heard about it before. In my case, it was like a very brief 3-minute presentations without any single slide, which was slightly confusing for me at the beginning because I have a very visual project, so I wanted to show some cool videos to, you know, to show what I will be doing. So now I had to describe it, kind of unusual experience, but it was like that. Then was 22 minutes interview, super fast, you know, just one question, another. In my case, it was mostly questions about method and theory, so I didn't get any of these HR questions that are sometimes outlined as an example of questions that you can get. I did a number of mock interviews to prepare for it, and I very much recommend it. It helped me to, you know, get my mind set on this kind of format, which was slightly unusual. I also got some like one-on-one presentation feedback session to make sure that what I'm saying is kind of understandable, to kind of ensure that the speed of what I'm saying is appropriate, because I have a tendency, as you can see, speak a little too fast. I tried the technical setup, which was extremely important. My huge recommendation is to actually try the exact same setup you will have for the ERC interview before, to do audiovisual testing and try to get familiar with the whole technical requirements that are there, because it will make you much more calmer when the time comes for the actual interview. And I'm very happy that I had some support from the faculty, that, you know, I had an IT guy, you know, behind the doors in case something would go wrong, you know, in the actual interview, that also make me kind of calmer, because, you know, I mean, your career basically hinges on 20 minutes where everything can go wrong very easily. Thanks to Odbor. But eventually I managed to do quite comfortable setup. The best advice I ever got throughout the whole ERC procedure was to stand when I do my interview. Almost no one does it, and I very much recommend it. You know, I'm a teacher at the university, and I'm used to speak when I'm standing, and I realize when I stand, I speak much better. It's much more natural for me to formulate ideas. It's so much better, and also your posture looks much more natural. You just like look in the same way when you are teaching. So eventually my setup was like standing. There were like 3 boxes, you know, laptop, and then I was speaking with the laptop, and it was that was kind of perfect. I felt good for the interview, and yeah, recommend it. Another best recommendation was cut your presentation a lot. So I think I started our 800 words, and I finished, you know, with some 43 minutes. And my general recommendation is to, yeah, go even shorter that you want, yeah, and just make some breaks and pauses in the way you speak. It's much more convincing. It just works better. I recorded it many times. That was very painful to hear myself speaking, but I did record it, and I realized that shorter presentation with some breaks and some emphasis on some words really works better, and it's more convincing. Yeah, and my general recommendation is, sure, I mean, get as much feedback as possible. I mean, this was crucial, right? I mean, I attended workshops, I organized different presentations and mock interviews with friends and colleagues. I contacted a number of ERC grantees to attend my mock interviews, and almost everyone accepted it. So I was extremely happy that they did, and they gave me an invaluable feedback on my presentation as well, both the oral one, but also the proposal itself. I did work with some colleagues from abroad who gave me, again, a little bit different perspective, even with those who didn't get ERC but have like a different view of some of colleagues in my office or at my faculty. yeah, generally when I was counting, there were like 35 people who attended my presentations or gave me written feedback. There were also many others who participated in these externally organized workshops, including the TC ones, which I quite recommend. Yeah, I feel that without all of this, like sometimes very harsh and critical feedback, the proposal would be way, way weaker, and probably I wouldn't get it. So I, again, rushed a bit so that I have like extra 10 minutes and have like a chance to answer some more specific questions. I'm not sure if this is the time or should we wait? Yeah, this is the time. Okay, so in case anyone has any question, I'm happy to answer. Sure.
Yeah, thanks a lot. Congratulations. Well,
Thanks.
I wonder, because I have similar problem of like probably a lot of costs concentrating on the data collection, experiments and everything. So what was the reflections, because it was a risky strategy as you said, what was the reflections from the evaluators?
I didn't actually get any negative feedback on this from the evaluators. I got a lot of concerns from admin people here because they found it unusual. They were not even sure if it's in the right budgetary part, right? Because, you know, this is kind of, you know, for some people, when you say that there will be a company collecting data for you, this sounds like the third-party service that they are kind of, you know, asking another party to be part of the proposal, which you have a possibility to do this, but I try to explain that this is like a basic service that you get. And eventually this was accepted. I didn't get any negative feedback from the evaluators. So frankly, I would do it. I think that in the project proposal, this can be very well justified. Yeah, I mean, collecting data for throwing experiments is time-consuming, but also very costly. And, you know, especially if we are working with professional companies like Ipsos, yeah, that kind of requires some substantial investments. But again, my recommendation is when you have like this written part of the budget, when you justify it, I would really go as far as explaining, okay, so in my previous experiments, when we worked with this company and we had this sample size of this size in this country, this is the cost that we get. So based on this, I'm calculating it and I'm trying to kind of extrapolate of how much it would cost to do 5 more countries, larger sample, different experiments. That I think that was generally evaluated well. That, you know, we justified in the proposal of what we want to do and how we want to do it, and then how much it costs. Thanks. Any more questions or comments? Sure.
Thank you very much for a very nice talk, and congratulations on your ERC grant. Yeah, you mentioned that despite the fact that ERC is claiming they're shifting away from evaluating CV so like harshly, that you still get the many comments on your CV. So can you maybe tell us more like what they were like commenting, like the reviewers, what was their focus on mostly? Or what was like the appreciated, what was less appreciated, and so on? Thank you.
Yeah, I feel, you know, there's another topic is to what extent and how the panel itself takes this into consideration, right? Because they have instructions of, you know, what weight to give each of these aspects. At the same time, for reviewers, this was obviously an important thing. I mean, they did look on my publications. They did, you know, despite all these discussions that it doesn't matter if you know, publish in high impact journals or it did matter to them a lot. I mean, I would say that another good advice that I got from some people is that despite all this talk about, you know, frontier research and, you know, high risk, high gain, you know, approach, I mean, they still want to see a feasibility. I mean, a lot. I mean, that feasibility is extremely important. You need to show that you don't only have like a risky and cool idea, but you can actually deliver, and it's important to them. And frankly, this will reflect in many of these reviews when they basically says, sure, this is very ambitious, but, you know, this guy already has publications in Journal of Conflict Resolution and Journal of Peace Research, which are, you know, Q1 journals. So we are confident that, you know, he can actually deliver and actually conduct research in a way that is convincing to journalists in the field, which means that it's convincing to, you know, people in the field, right? I mean, that the reviewers that are reviewing for this journal are usually prominent researchers in our field, so they are convinced by the approach that this person is taking. So they definitely focus a lot on publications, on some, yeah, on I would say that was the main aspect. I mean, there was also experience with previous grants, right? So there was an idea, okay, so if he was already able to conclude some really high-profile grants before and deliver, it's also quite a good chance that he would be able to do the same thing for the ERC. So obviously, I know that this is not the best advice you can get, like get a better CV, right? I mean, that's kind of hard to do at some stage, but I wouldn't underestimate it. I would definitely still keep in mind that this is evaluated by people, and for people in our field, these things matter a lot. Maybe the last question. Yeah, sure, Teresa.
Is it on? Okay, it is. Thank you so much. I already said my congratulations, so, well, again.
Thank you.
But I have there's still some time before before I like to submit my ERC application. So I haven't really started thinking about it, but, and also learning about what is required from it. But you mentioned that the project idea should be somehow different and break away from what you did up until now. Maybe can you say a bit more about what that means? I'm sorry if this is not a great, maybe you're not the best person to ask that question, but...
Yeah, that's actually a super important question, and I feel that like a lot of negative feedback I heard towards other projects was simply, I mean, this person continues business as usual, right? I mean, that they do something which is comfortable to them, that is basically like a follow-up study to what they already do. Sometimes I'm now, for obvious reasons, now I'm reading so many of these proposals because so many people are sending them to me for comments, but very often it like feels like, okay, so now I want to do the same, but bigger, right? I mean, now I will have more money, so I will do more experiments, and I will go to more countries to do interviews, and I don't know, I will just collect more data, and it will be just more ambitious, but more or less the same. And yeah, I mean, from what I heard, and I have never been on an ERC panel, obviously, this is an issue for them. They want to see that you actually go to like a new sort of uncharted area, but that you also can demonstrate that you can do it. So in my case, what I did, and what was like the novelty in my case was, okay, so I have a new empirical focus. It's an area that is new for me, right? But it's still part of international security, which I studied before. So I kind of understand the domain, but I don't feel completely familiar in this idea, and this is where I found some substantial gap that I'm trying to fill, which is major, it's new, it's unique, but sure. So that was the empirical aspect. Then was the methodological one, where I already demonstrated, okay, so I conducted a lot of experiments. I've published a number of experiments in high-profile journals, so I know how to use the method. But I'm trying a new method, which is still based on similar experimental reasoning. The methodological approach is overall similar, but it's including, let's say, some new ideas in terms of design that can be quite a breakthrough in my field. For example, if the method that I'm now trying to use would be used more widely, it can provide the respondents with more convincing, realistic, scenarios in which they can get much more attentive and much more in the situation. So it can actually provide us much more accurate predictions about their actual behavior, if something like what would happen. And I didn't have an experience with that. What I said was that I did some pilot study, which I did. So I believe that can be quite useful, but I definitely wouldn't go as far as I saw some projects basically said, okay, so I already have some data, so I'm kind of continuing, I already have some data collected. I wouldn't do that, really. You should really show, okay, I tried it, I know it's feasible, I know it for a good reason, but I'm still like going in an uncharted territory. And then I had the theoretical innovation, which was really, again, about, once again, working with public samples, but I put the elites in the game and try to look for these feedback loops between elites and publics to show that, there is some kind of like a new theoretical innovation, which, again, I'm not really sure how it will work. I have some theoretical expectations which are sound. It's kind of there is a bridge to what I did before, but the innovation is substantial enough to justify like the argument that this is like a major theoretical breakthrough, at least potential. So then in the proposal I had like these three areas, empirical, methodological, and theoretical, that I tried to put separately and explain how in each of these parts I'm actually doing something really new, both new in the field but also for me myself, but still like to always put their hints to convince them that I can do it most likely. That's the idea. All right, thank you.
Thank you very much. Just one note maybe before we continue, because the question about CV and project, that's quite an important one. CV, like now ERC is moving more towards the quality, and CV is kind of being pushed to the background, hypothetically. Of course, it's, as Michal said, it's the people who are doing the evaluations, and depends on the field how they take the CV. But feasibility is really the key word there, and I'm saying it as I'm sitting on a panel, so I have this kind of NDA, so I'm not saying anything new, so I'm just confirming what was said. I'm not leaking anything, hopefully. It's being streamed, so we'll see if they kick me out, but it's not anything new. But the feasibility or the feel about feasibility can be correlated to how strong your CV is, because if you've already shown or you had shown that you can deliver, then you can be riskier in a way, and if you are riskier, then you are probably showing some innovative approach, so maybe you will be better evaluated, but only if you show that you could do it before. So there is this dynamic, and I think it will take a few more years before we get to the position where the CV doesn't matter much. It still matters, it's moving more to the background, but there is still this correlation between feasibility and how they, at least from my feeling. So thank you very much to Michal Smetana again from the Faculty of Social Sciences, and we will move from peace to peaceful fish, maybe. And I will invite Zuzana Musilová from the Faculty of Science. It works.
Good. Okay, hello everyone. I'm Zuzana, and I'm from the Department of Zoology, so I have a project in the life sciences, in biology, and I just put a few things about my way on the slide. So I did a postdoctoral stay for quite, I would say, longer time, for 5 years in Switzerland, and then I was coming back to the Czech Republic when I intended to start my own group, and I was awarded the Primus project with the extension, so it's still the former format of 3 years plus 2 years extension, and then during the Primus I also applied for the ERC, and I've been lucky to be awarded in the past call by the consolidator, which started in July 24. And I will talk only very briefly about my project, because many of you are from different fields, so you don't need to know the details of how I will do the genetics of the fish. But I wanted to show it to you anyway, because I will use the exact same slides I used in my ERC interview, so that also might be somehow perhaps helpful for someone. And I just want to second the previous talk that every panel has different requirements on the interview. So in our case, it was 8 minutes with presentation. So this is something where you really have to pay attention. I mean, it's been the presentation I really spent so much time with. I never done that before. I even wrote down, like word by word, what I will be saying, which I was completely against, and I felt like this is so boring. But then when I did it and everyone told me, yeah, do it because it helps, I realized that it was actually a good thing. So you really want to know, like you really want to have everything prepared, and absolutely no way you would be longer than the given time, because then they would stop you, and that would be not a good thing. So I will start with that, and also maybe one comment now, because we already mentioned a lot about the CV. For me, as I saw it, it's actually not called a CV, but it's called a track record, which means that it's, of course, based on your CV, but you somehow are meant to explain how what you've done in the past is leading you and why you are the good candidate. And you, of course, you should have some good publications, but it doesn't need to be the top publication, but then you justify, so based on this, that led me to that way, and so on. And I've seen also track records which were really good. That the candidate, for example, stated that his PhD students or former PhD students or his former members of his lab were good in science later. So kind of like that your role as a mentor or past supervisor was also strong, and you kind of educated or directed other people to a scientific career. It's also something which might be valued in this track record. This is more for the consolidator or advanced grants though, but still. So, okay, so I'm going now to the project very briefly. So my project was focused on deep sea fish vision, and I used deep sea fish as an example of extreme animals, as you may see, and still they are vertebrates, so they have the camera type eye, so we can really see the limits of what the vertebrate eye is capable of in the extreme conditions. So. Deep sea fish are truly bizarre creatures, so that helps visually also to get some attention. And they live in the different or difficult or challenging conditions because that's the darkness and or the almost darkness of the deep sea, where they have to adapt or they have had to adapt in their evolution to see well. So. We actually find a lot of extreme visual adaptations in the deep sea fishes. So if you ask me what vertebrate has the most of this, or most of this, or most of this, it will, in 90% of the cases, it will be some deep sea fish has that. So that's why they are like extreme, and that's why they can also tell us something about where the limits are. So my project was based on the previous findings, so I of course tried to use that in a justification, but I already found in the past with my colleagues that there is an extreme case of adaptation of one of the deep sea fish species which has a duplication of rhodopsin genes, and this is something very unusual because rhodopsin genes are in most of the vertebrates there is only one copy. It's a very conservative gene, so you all know that you also have only one copy of the rhodopsin gene. That's your rod cells in the retina, what makes you to see at night. So we can see only black and white at night because we have only one rhodopsin. But there is a fish species which has 38 rhodopsin genes, and these rhodopsin genes code for the proteins which are differently sensitive. So their sensitivity is somewhat along the light spectrum, and this is something very unusual. Nobody knows how it works yet. So this is what I said, and I said, so I want to find out how it works. And just to give you an idea how the system might work, I will just now show it to you projected on our own human vision. So you know that we are trichromatic during a day. We see in the blue, green and red channel, and this is mediated by the cone cells in our retina. So it's cheaply in Czech, but that's the cone cells which work at a high intensity of light. And now if I project the spinefin, the fish visual system, on top of it, you can actually see how very crazy this is, still between our blue and green cone sensitivity, and it's using rod cells. So rods are the tyčinky in Czech, the second type of cells in retina, and they are known to be sensitive in low intensity of light and never ever been involved purely in color vision. So this would be something nobody else, no other animal known has actually this, so that's why it's weird. And yeah, how the system works we don't know, and maybe some color vision by rods perhaps, but we still don't know. So that's how I wrote it. So I wrote my proposal based on the findings, so it's not that I'm completely forgetting what I did in past, but I spinned it the way that, so I did some finding in the past, and now I want to focus on one of the things and do as many, let's say, methods or novel approaches to really investigate it better. So it was not a continuation, but it was based on the previous findings. So it's not completely, in my case, it was not completely out of a scratch new thing. And yeah, because I said that it's still a camera type eye, then we can then relate it to what we know about vertebrate eyes. These are already more detailed things about what we know about the gene expression, the rhodopsin expression in the retina. We know from the past the overall ratios of the different rhodopsins, so we know they are expressed, some of them, but we don't know how it is organized in the cell. And my main or core approach was the single cell level, that I can sequence the retina where you get the transcriptome or RNA for every single cell, and that can actually tell us if every rod cell would have all of them, then it would perhaps mean that we have super powerful rod cells, but no color vision because they would be all the same. If there are different rod cell types, that would be on the right scenario number 2, on the right for you. That would perhaps mean that the color vision would be possible. So this is basically the main, the central hypothesis of my grant, and that was explained in the proposal. Then also, like, I try to justify why because you are meant to justify why you are applying for the ERC. So I spin it the way that the deep sea fish, as you may imagine, those are extremely rare samples. So I even got questions during different workshops on, like, what if you are not able to convince them that you are able to even get the samples? So something I didn't think of, because why would I write a project if I would not be able to get the samples? But it's true, so I really put also some emphasis on, okay, I really can get them. I can go on the cruises, I have collaboration, or we can get them. And we also have some samples from the past, so I put the photos of some of our past samplings, but they are rare, and it's true that you need to have established the collaborations to be able to sample properly and specifically for the proposal, which I had to explain that it's the case. It's still not as easy, so we are still waiting for some samples, or yeah, let's hope it will work. And I also put like that I'm using like the current the single cell sequencing, what I mentioned, is actually the very new thing to be applied now routinely. So it's really now the time, so that's how I said, and I think it's true. So now it's the time that we can finally use it. So the method is here, I can use it on these rare samples, and I can now answer the questions which have been standing like around for tens of years or for decades, and now we can finally address them because we can go on the single cell level. So, right timing, rare samples, great methods, that was how I spinned it. And then, yeah, because they are vertebrates from extreme environments, but it's vertebrate, it has kind of potential to have some general findings which might be relevant then for the vertebrate eye, which at the end of the day we are also vertebrate. So you could imagine some possible outcome which we can't expect, we can't predict, but could be relevant for even like a more general conclusions. Yeah, and then of course the purely biological naturalist perspective is that like we can learn so much from the molecular approaches about how the animals or how the fish can see what they do, but some of them no one has ever seen them alive, so all we know comes from the deep sea sampling. So it's also very, very different from the fields where you can easily get your samples, like going for some days in the field. Wherever. So this is, and this is still true, that's not only my research, but a lot of what we know about deep sea fish comes from the captured or fished specimens, which most of them no one has ever seen alive. Yeah, so that was basically the main narrative I used during my interview and the grant. Of course, there were more slides then going more specifically in the work packages. I'm not showing them here, but like that was the introductory slides. And now I will I will tell more about the journey of the project. So somewhat similar to what we've seen in the previous talk. So I applied on the ERC. I don't know what was the call, but the deadline was in January 23. So more than 2 years ago, and the overall idea of the project, I had, already like a year before, but as I will show you later, I was thinking about the project much longer. But let's say I had the idea, okay, I'll do this during 2022, and my original idea was much broader than the final proposal was. And here I would like to really say that the great thing is these workshops organized by the Technology Center. So these are that was really great feedback, and it's a specific workshop which is like specifically meant for applicants who already have written the B1. So you already have to write the B1 proposal, which is the part of the ERC proposal, and the workshop is working with your proposal. So there will be several people who will read your proposal and give you the feedback. And these people in the workshop group are mainly the members of the ERC panel, so they know, and also they are kind of from your field. Let's say it's a biologist, but it's not your field, so you will get the feedback like, this is not clear, it has to be more generalized, or general feedback. And you really get critical feedback, which I think it's a good thing, because in my case, it really led me to, I had to cut a lot of things away to focus properly on the one thing I wanted to really have there. And at the end, it was way more kind of elaborated what I wrote in the final version. So that was different from when I sometimes write, or when you write sometimes other grants and you do like a bigger thing, but then there's no space to go into detail, or not detail, but in the more elaborate way how to do that. Anyway, so the thing which was with this workshop is that you have to write it way more before the deadline. So I had to send it in August 22, even though the deadline for the actual ERC was only in January, so in 6 months or 5 months later. Because they had a joint deadline for the starting and consolidated grants, which it may feel, if you are a deadline person, it's just, oh, like might be right in half a year before the deadline, feels weird, but at the end, in the end, this was actually very good, because this pushes you to write it down, and then there is some time, and even you read in your text after some time, you will already see a space to improve. So that was a great. There was time for the proposal maturation, and so on. And then, of course, you write the B2 proposal in the meantime. So there is, thanks to this workshop, there's also enough time to do that. Then I submitted the proposal in January, and I also was pregnant, so my daughter was born 1 week before the deadline, but I submitted, of course, before, so that was everything, so double happiness, so that worked out. And then I was invited for the interview, which of course, I was happy. And then there is another round of this technology center workshop, which were even more, like I would say, even more intense, and you get a lot of feedbacks again and mock interviews. And the interview was, and I think it still is online, which means that you are online, but the committee is there in person. So you can see that there is a big hall where everyone is sitting around the table, and there is a big screen like that where is you speaking, or your presentation is there. And yeah, I had it in my office. I had the computer on the printer. I had a phone with the light on my face so that I am actually visible. So it was a setup. I locked myself in the office, and I trained a lot. So the presentation was okay. There was kind of no, if you really prepare well, that should be fine. But then there were the questions, and then I got stuck with the very first question, even though I expected it. Somehow my feelings were not very good. So we've got in some situation that I started to feel like at some molecular biology exam when the person wanted to hear something and I didn't say the exact phrase. And then only later I realized that I'm like doing like this, you know, and then there is this room, and then there is only my nose on the screen and nothing else, because I was moving like that with the head, and I was like, oh my God. So this first question was a bit disastrous. Then I responded the other questions quite okay, but like, I think so I really had bad feelings, and I was actually sure I will not get it. So I started to prepare the new version of the proposal. I still had 1 year to apply because of my daughter, so I got the extension. And then also look at the timing. So the new deadline was in December, and in September there was only the interview, and only in November they announced the results. So I already have improved my original proposal, and somewhere towards the end of November I find out that they actually gave it to me. So I was like, oh. Wow, so that was really unexpected in my case. I got the evaluation, and it was even written there that I was able to answer all the questions except for the one about this and that. I'm like, yeah, okay. So still, it worked out in my case. So I was like, yeah, I'm very happy that it worked. So this is how it was, and then I started in July. So I will have now some few slides what I've been asked about the Primus, and then the complications, so like the experience. What I faced. For the ERC I also have some experience, but of course I am still in the beginning, so I think there is like a certain evaluation period after 3 years of your grant when I may still face something else, but for now it's all good. So I just put here some points which some of them, like many of them have been already said, so I don't need to go through of them, but in my case, my Primus proposal was different in focus from the ERC, because that was my original idea many years ago, when I thought, yeah, one day I would perhaps apply for this, which was like a hybridization and polyploidization and fish, and then the effect on the sensory systems. But then after several years, I found it kind of boring. I was like, no, I don't like it. There is no space to write some like exciting proposal, so I changed the plan, but I still did the Primus, so that was not boring doing the stuff for the Primus. And I also, in my case, I missed the window for the ERC starting grant, so I have a consolidator, but I was somehow late with everything in my career, so I missed the starting grant window because that's only maximum 8 years from your PhD defense, and I still didn't get like good track record or like I knew I have some good stuff to publish, but it hasn't been published yet, and that happened only in 2019. So only after that I felt confident that I could start applying. I applied for the Primus first. I was already in Prague because I already had the Gacha grant, but I still had quite new research groups, so that was like to really like support and like increase my research group size. The Primus was actually excellent, and I would like to say that what's been actually said, that is quite straightforward, both the application and also the yearly reporting. I think this is important, and plus the freedom kind of in the research. So if you decide during the project that one of the paths might be more promising than the other, you can really kind of deviate, or you can change your focus within the certain range, and you don't need to like explain or ask for that. You are really free, and I think this is important in the early career of the PI, that you are still trying to find the idea. Also, I could see the Primus as the like project to really try and test certain ways of which then you can later apply or for ERC or not. But yeah, maybe I should slightly hurry. So my recommendation was, that you can test some wilder or risky ideas within the Primus, which might be a bit different from the Gacha, where everything should be more realistic, or already having a pilot for everything, I would say. With the ERC, the recommendation is that you develop the idea and you start. You will have enough time to write it. If you are from Charles University, then get in touch with the faculty coordinators. At least at the Faculty of Science, we have a good person called Ludmila Součková who knows and who will tell you also about the timing, like don't forget to get inscribed to this and that workshop. So this is it's super helpful. And definitely attend the workshops. It's really helpful a lot. I think I'll skip that. So complications. I put a lot of things. You don't need to hear it. Maybe for the Primus, I won't even say. So there are no real complications actually with Primus. Maybe some people might struggle a bit with the departmental contribution, because you have to negotiate it, but. at the like on the other hand, it's good if you negotiate with your future employer somehow. And the other good thing on the Primus is also that the reporting dates are not colliding with any other deadline, so it's another thing. So someone really thought that through when it was made so that it's done well for the PIs. With the ERC, I personally had minor issue with hiring new people, but that's not like, it's not a systematic problem. It's just in my case, even though the person I selected, the PhD student, agreed, she later declined, and it was after the application for PhD, so kind of I lost the whole year. I know you can now apply twice a year, so you would lose the half year, but I decided to keep it, so I'm hiring now again, and all my investment, which was several days, and the interviews is actually got in vain. So that was my experience. And then also, like, we are fighting all the time with the administrative support, so it depends on the interpretation of your institution of the rules. So we have a rather strict interpretation, I would say, so we are still trying to find a balance of what we accept and what not. And yeah, I also had a situation that only after I got the grant, someone told me, oh, you need to employ this another person for the administrative stuff, even though I had my own group manager and the administration for the group, but there is a lot of other administration, and I somehow expected that the institutions should do that. So that maybe the suggestion is that try to negotiate this with your institution before you apply for the grant. I know it's not easy. And then maybe the last comment about the overheads. So if you at your institution get hands on the overheads, it's good, but if not, quite some things are not eligible for the direct funding in the ERC, because if it's not specifically used only for that, like computers or whatever office stuff, it might not be eligible, and then you use your overheads. So if at your institution the overheads are not on your disposal, you actually want to make a deal in advance. So you can do it. I know a person who specified it in the contract during the installation, so that the institutes will actually cover you 5 computers and this and that, because those are things which are not, like in the other grants, eligible. So I think, yeah, that's my last slide. So yeah, I was a bit longer, but I'm happy to talk to everyone if you want, if I'm not having time now to respond to questions. But yeah, also the team is crucial, and of course, yeah, I think the experience with how it is with hiring, I can actually talk about it maybe in some years if it was successful or not. But yeah, the team is of course crucial. Okay, and with that I also thank you for your attention.
Yeah, I think we have time for 1 or 2 questions.
Okay. Yeah, or come to me during coffee if you don't want to ask now. So do I still get now? Okay.
Thank you very much.
Okay.
Thank you very much. I will certainly, like tonight, I will think about whether I actually see black and white during night. That was new information for me. Maybe I didn't pay attention in basic school, though. But so thank you very much for that. It's a good thing for me that even though, because I wanted to ask about the starting part, but you said it yourself that even though you didn't apply for starting, we can see that there is a chance, even if you don't have the starting experience, to do the consolidator if it's done properly. So that's great. That's a great thing to hear, certainly. So thank you very much again. And now is the time for Professor Zdeněk Strakoš. Why to submit ERC? So please, Zdeněk, if you may.
Good morning, ladies and gentlemen. I first have to apologize that I'm late. It's not entirely my mistake, because we are now in a very difficult situation with one issue which is related to support of the ERC in check, and I'm kind of yes, I had to do some urgent things, so that's why I'm late. Sorry for that. So, from which position I'm talking to you now? I will not have any slides. I decided just not to have, like the other years, because I think it's better if I just talk to you and if we have a discussion afterwards. Or in the meantime, you can jump in anytime. First, I served within the ERC from the very beginning in the panel for a couple of years, and then I became a chair of the panel. So I had a full load, I would say, of this experience. And then we started together with the time Petra Perutkova, the national NCP for the ERC, this support that grows now into, that it growed and growed, and now it is the system of the workshops. We'll just mention them quickly. Just a little thing, it's now become a synonym. Workshops organized by the Technology Center, that's correct. They are organized technologically by Technology Center, and without that it would not be doable. They do it perfectly and do everything for us. But there is a group of people that is behind, and it's about, say, about 12 people who really do the organization, of the program, and about, say, 40 other people who participate. And they are not affiliated with Technology Center, they are independent. But it's a kind of very nice symbiosis, an example how things can work without money, essentially, so not always everything is based on money, also on some other say values that are much more than money. Okay, and not only that, so I'm responsible for this workshop in some way. So if you feel kind of unhappy with that, so I am the person who should be punished. And then I'm also responsible for coordination of the help at the university. I cannot reach faculty, every single situation that's difficult, but we are trying to do it. We are trying to support the say, organization of the help at faculties, but we are also trying to support the people individually. And I would like to mention also Veronica. Veronica, please stood up, because Veronica is my right and left hand, so she's helping me to survive doing this all things. And I think she has learned very quickly. She is very now professional within the RC things, and once you try to apply or whatever, you will have a lot of contacts with her, or the useful contacts and very pleasant contacts. Okay, so I'm this kind of three roles in some sense, and so I will talk a bit from all of them, from the symbiosis, but mostly I would like to motivate you to apply. So I'd like to explain why we should care about ERC. So why not to get Primus, and after getting Primus just go to Gacher and stay with Gacher forever, or at the best go to Junior Star or X-Pro and then stay in Gacher forever. So why we should do it differently? That's there are many answers for that, and I also, some of them were published in some even recently, and some of them were also in some recent say podcasts and things that are distributed. But the main thing is that simply we are the part of the world, and I am rereading again the Lord of the Wings in English, and there is one very nice, well, many nice things, and you know that, of course. So there is this way how Bilbo, not Bilbo, Frodo is escaping the Shire and escaping the Dark Riders, etc., and then for a little time they found some shelter with a group of elves, and then everyone sleeps, and he speaks to this elf, and they just met for one day and one night, and then this guy and Bilbo is saying, well, I would like to be in this shire that was so nice there, and I would just like to be there, not to interfere with this outer world. And this elf tells him, you know, it may happen that you create a fence around you, around your shire, and with this fence you will try to you will try to eliminate anybody to interact from shire with the world. But there is no way you can eliminate the interaction of the world with you. That's exactly it. If you make a bubble around us, we still the Czech science is a Czech science. We are here because we are Czechs, so we have Czech science. And we'll talk about that in this sense. And we isolate ourselves. I'm not going, what would be the end? I'm not going to tell you, the history showed that many times. Simply a part of the world. ERC is there, and if we just don't interact with ERC, we don't use this opportunity, well, it is not for good for us. That's it, that's that simple. But, so that's why we should care, because it's a standard now. If we do good science, really, then I think the standard is just to try to get money from over there. Not only money, but simply be a part of this. But now I'd like to talk more about why, in other sense. Because ERC is essentially in the very root based on why. Why is the essence. And it's not the essence for the ERC, but it's the essence for the science itself. Because we can find very often, nowadays even more often, when we are buried under a lot of information, just, you know, trying to get us from all sides. I mean scientific information now. So we look like that sometimes we are buried under that. And the individual fields are many times kind of closing themselves. I know it within my area, I'm a mathematician, and mathematics is now totally fragmented. People from different fields but are sometimes connected, they don't understand each other many times at all. The language is different. They don't speak to each other, they don't care even. It's terrible, absolutely terrible. So that's why within the ERC, okay? Because within the ERC you have to think about your project, about the question about the deep fish. I like very much, Zuzka, that one of the fish was actually swimming. The others were like sleeping over there, but one was swimming nicely. So, you know, why my problem is important. Not that it is important from my keen, close bubble. It should be science as it, an sich. Okay? So that means that it should be a question that is important and interesting, but not only for myself. And the main issue in getting ERC is to explain, being able to communicate to the evaluators, yes, really, this is an important issue that I would love to work on too if I have time. That's the path towards getting. But this is not a question of some kind of say, psychology of getting some money or whatever. This is important for the science itself, because once I see what is the place of what I am doing and what I like to devote, not only next, as Zuzka nicely said, unfortunately I've missed Michal, I'm sorry for that, but I'm sure he was talking in a similar way. You know, it is not just a question of now I have this grant for 5 years, that's it. It's a research program, essentially. It will, if it is really it, if it is really like ERC should be, it will keep you working for much more years, much more time than is 5 years of the grant. It will just open you the path that you like to go. Maybe the path will go a little bit different way than the originally thought, but there will be your path And that's what the ERC is, a research program. So you should always ask the question, so why this part is important and why the others from the neighboring fields and maybe from your different fields should think, yes, this is an issue which should be given the money to be explored. So giving the money is a kind of a secondary issue, but this importance of this itself is very important. And now this leads us to another question. So if we think this way, and that's one of the biggest benefits of the ERC for these years that I kind of am involved in that and in working with great people that I'm very thankful for, that I can meet through the ERC, I mean with you, for example, is, you know, that if we are able to, or if we work on this, and if we think this way, during the preparation of your grant, that you have to have in head not for a couple of months of writing, no, for years. It must grow. The idea really must be nourished, and it must maybe the particular finalization is a question of a couple of months, but this must grow from the background that you must have in head for a very long time, okay? And what this preparation for the ERC grant and submitting a good ERC grant do for you, it will help you to clearly think about your problem. And believe me, that's something that you will not get otherwise, because you will not be forced to think about it. Okay, so how should I formulate this in order to make it understandable for the others? It's a little bit like when you teach and when you take your teaching as a mission and you really care for your students. But now you're in a different position that you don't talk for the students that are learning, but you are talking to the people, say, who are more experienced as you typically. In general, I mean, not in the particular question. The particular question, you are the person at the moment. But you must be able to explain that clearly. And this is not very easy, but this is not just the exercise in writing. This is just exercise in how my brain should think about the problems. Okay? It's a totally different thing. And believe me, this really does. It will change the way you will approach things. So that's I think it's the most important thing on the ERC, and most, I would say, the biggest opportunity that we have. It will grow in developing your talents, in maturing your talents. That's why we need it. And no other way, I mean, comparable, I mean, this grant application has the same power, because the preparation is much less challenging. Say the environment or the people with whom you will compete are not on that level, definitely. We cannot have on national level the same environment as the ERC. We cannot do. We can only kind of mimic some parts, which is good, but we cannot create like Czech ERC. That cannot work. So this will ERC, that's what the ERC will do for you if you decide. And that's why after you get Primus and you will build up your group and you will try, if you feel that I'm strong, I mean, might not be immediately, it might be a little bit later, but when you feel now it's a time, that's why you should apply for the ERC. Because it will really change your way. And that's why you should prefer ERC to some Czech parts, because the Czech parts will maybe move you to a good level, and you still can become a very good scientist, etc., etc. Yes, there are such people, and we must not make a distinction between those who have ERC and who don't have ERC. That is a nonsense. But if you just feel that yes, I'm ready, and I would like to really to explore this question. I feel this power in myself, and I also not only that, but I would be happy to be responsible for others, to lead them. Then you should go for ERC. You should not go for any Czech alternative. Or if you go for a Czech alternative, you should consider it as a first step towards the ERC. And that's how whole Czech support, of grant support, should be refocused. That it should be really kind of a preparation for something which is more challenging and more important, that maybe not everybody can reach, but some of us can. And they can reach it for us. And again, I don't mean about making some, community of people who have and those who don't. The community of ERC grantees and the people who applied for ERC is a wonderful community in one sense. There is some community, but they don't make any borders. They don't make a fence around. They are ready to help. Everyone is ready to help others. And it has the spirit of kind of openness, not closeness, openness. And that's what we need. So of course, independence, that was said here before already, so I'm not going to repeat that. So that's, I was trying to explain by what is the relation between the Czech grant system, hopefully will grow in a good way. There were some good changes in the past, and such programs like Junior Star and Expro are good, definitely, and the ERC. But you should not buy this, what is for the people, even some top people, are trying to sell here for decades. Like ERC, this is not for us. This is just maybe something on the top of the cake. But this is a nonsense. This is just the basis for transforming the Czech science. During this, what I have explained. Okay. So. Maybe a couple of things on this way what the ERC relies on. The ERC relies on originality, and this is always a kind of dispute. So what is originality? So how I came to that? So now I will be original. Yes, that doesn't work that way. Originality grows from the fact that you do whatever you do the best possible way you can. That's how the originality grows. And how it is with ERC, so is it true that it must be something like completely new, doesn't depending on my previous work, etc., etc.? No, this is not meant that way. There was a lot of misunderstanding about it. And ERC is working step by step on trying to clarify these formulations, just not to make confusion. There must be an idea in the ERC grant that really is new. So there must be definitely an idea. But this idea is not that, I'm working in mathematics and now I will jump to a field that I have never heard about. I will have an original idea. That's a nonsense. Originality grows from work. So that must be, it definitely will be rooted and connected with your work before. But it cannot be just the continuation. So I did this and developed these tools from the past, and now I'll just apply them to, I will just continue. That would not work. So in this sense, it is important to have an idea. That's why in these workshops, when we start, the first workshop is about, please give us, what do you think is the point that you like to develop? What do you think would sell your future proposal? And then we try to discuss and think, yes, is this strong enough that within, say, 1 year or 3/4 of the year, whatever, this idea would be developed in a full-scale proposal. So the idea must really, you must have some idea which others will say, oh yeah, well, that's interesting. I haven't heard about this before. Okay, that must be there. But it doesn't mean that it's unconnected with your work. It cannot be. This is wrong interpretation of this word. So that's important. And also, what is very important for us here, because we, in this country in particular, we live in this kind of culture of depression from failure. I would call it that way. You know, the opposite, sometimes in the world, or many times, even in science, the success is like the success. You should report success as quickly as possible. Publish as quickly as possible, you know, and the first decile or whatever, you know. This is not for ERC. ERC doesn't go that way. Exactly against that. ERC is not about reporting success. ERC is about challenging some question which is really difficult and interesting. Okay? That's about ERC. And maybe something what happened, yes, some publications, yes, but this is just side thing. So not a success, but on the other hand, not a depression. And so in this country, if somebody applies for something and then doesn't succeed, then this is a failure. It's constantly, this is just completely wrong attitude to life. And we can see it from the students, from the very beginning, you know, not from the students, from the teachers, and from say, professors, you know, that, well, you know, I just, you know, he must did his PhD, and that's why, you know, better we will submit this paper to some journal that it would appear fast enough. Completely wrong. The students must be exposed to criticism as soon as possible, because they must create an immunity of the system, immunity to failures. Failures are positive in science, because failures will show you that, okay, this is not the path, but at the same time you appear that there is some dead end. It means that we have discovered something really important and that you have to go the other way. And that's what the ERC doesn't care for. It's fine. That's, you should not make promises and fulfill them. That's what Zuzka mentioned. If you just make a detour, or if you even change your original plans, that's absolutely no problem. Okay? So we should definitely leave this feeling of that if we don't succeed, that we fail. And we see it also even with the ERC, we see it directly that the people, I know some people who applied for the ERC grant 6 times and failed, and they got it the 7th application. In the Czech, many times it happens that the person doesn't get it, let's give up. Let's just be satisfied with our Czech or national funds, and this is enough for me, you know. And that's exactly this attitude of failure, you know. It's not that anybody would tell you are not enough. It's just, you know, and if you get some criticism, and sometimes direct criticism, it is not that they like to put you down, they just like to help you. That's exactly what we do at the workshops. So those of you who have experienced that can confess that we are sometimes very strict, but it's very clear why we are doing so. We are not doing so that we pretend that we are, you know, the ones who all know. We don't know. We just say what we think, but we try to help in the best possible way. That's why we must be direct. So please, we should leave this culture of failure. We should be self-confident enough just to say, this is my stand. I just think that this is important, this issue, and the others perhaps have a different view, but this is my view, and stand for that. That's why you then get the ERC grant. So this is, I think, philosophically very, very important. And so maybe I say a few words about this system of support. Anytime you feel, well, I kind of feel that I might be ready to apply for the ERC within maybe 2 years from now or 3 years from now, please let us know as soon as possible. We'll put you into the system, into the ERC pipeline, and you will be in our heads then, and then we'll bother you. After we'll let you know about the workshops, etc., and then try to find with you the real time. Okay, is this already is ready, or maybe it's premature? It still need to be a little bit more clarified or strengthened, etc. So that's important. So please do that. So because here at the university we can offer you just pre-help before entering the workshops, because workshops we co-organized, and they. Originally, these workshops were started here 11 years ago, because they were organized by Charles University together with Petra, who organized for us this technical stuff. And then we moved everything a little bit different way because it growed and growed. But so that's pre-workshops, but also after the workshops or in the middle. So we can help you in the way like by some even individual discussions and guidance, etc. Okay, so you're not lost. We can give you the contacts to the other ERC grantees that you might not know, for example, but we cannot do the work for you. That's something what we have experienced the last year, that we just said, okay, we'll not check that cautiously the input to the first workshop, because people were we had a lot of trouble with that, because when we didn't admit someone, so we got protests. Why this has not been admitted? We got letters from different institutions or even our institution or some faculties, why this person was not, simply don't have time, it was not good enough. So that's, and so we decided, let's do it first come, first serve. And the last year, quality dropped dramatically. That means the responsibility of the institution doesn't work, still doesn't work. If the individual institution are not responsible, we are not able to help, because we don't get good, well-prepared applicants. So you must do the work. We cannot be able to do it for you, but we can help, we can guide you. And this that you must get, you should look around. If you like to apply for ERC in the future, talk to the ERC grantees. We have already a couple of them. It's not like, and I started, so we have two, two of them in the Czech Republic. No, we have quite many. We have quite a few in this institution at the university. So talk to them, ask them what's the experience, etc. Many of them would be willing just to give you the grant, so you'll see, okay, how it look like, and share. So this is the thing that you must do. That's everyone outside of this county does. That's how it worked. Here, sometimes the people coming to the workshop and they are feeling like now they learn everything, they will tell us. It cannot work, we can only help, we cannot do it. So that's an important issue, which is also somehow related to this culture that I mentioned. So I think that's about all what I want to say. Maybe I forgot something, but it's still a little time for discussion, and I will be over there, then we can discuss still with me or with Veronica. And again, Veronica is really great person in all sides, and they will be very helpful to you to talk to her. So in some last very short video that is now traveling somewhere on the social networks. I'm not on them, so I don't know where it is. But so I've said something at the end that ERC offers a kind of quite a unique opportunity, that you can develop a long-term project and kind of you can say, okay, that's about the 10 years of my future professional life that I would like to devote to. You should think about it this way. It is worth or not. Because you cannot return the time back, when you will be 40, you cannot return back to the 30. So that's important to think ahead. But you may feel that, okay, that's exciting, I should go for that. But you should also feel the responsibility for the others. Because not only me, I would need others. And I'm really ready, and I'm really willing to work with them and to lead them. Because the best day what we can do, if from this seat, which is one ERC grantee, will grow the other ERC grants in the future. That's exactly how science grows. Science grows from individuals, not by decisions by some committees of the people of my age that would decide who should do what. That doesn't work this way. So that's why ERC is so successful. That's about all I wanted to say at the moment. May you have a quick question. I'll try to have a quick answer, and then I think we have lunch or something afterwards. So, sorry? Coffee break. Oh, we have coffee break. So I will be ready in a coffee break if you are, and also later on, but to be a little bit cautious because it's not entirely easy to get me because of these other things. But you can always get me through Veronica, so she will. But so I'll be happy to be of help in any way I'm able to. That's all.
Okay, thank you very much. And now we have, how much time? 15 minutes. 15 minutes for the coffee break. I kept thinking about a Lord of the Rings stuff. You can't do this to me because then you lose me completely. And I looked up that in the movies, it's actually Pippin who says it to Treebeard, so they changed it a bit.
There'll be even drinks over there, okay?
Yes. Okay, so let's go to the coffee break, and in 15 minutes we'll meet back there, so that's 12:15. Okay, so welcome back. After the coffee break, now we have the session on, or with selected Primus grantees. We'll have 3, and we will start with Ján Antolík from the Center for Theoretical Studies. The floor is yours.
Good afternoon. Thank you for the invite. So I will briefly talk about our research group, which we kind of created because of thanks to the Primus grant. You can read more about what we are doing at acsresearch.org, and we are part of the Center of CTS here at Charles University. So I will start with a bit of big picture. So you probably noticed AIs are getting like more and more powerful. The plot on the left is like how much compute is like being spent on training the frontier like models, the most capable like machine learning models. It's not clearly visible, but the scale is like logarithmic. So the amount of compute we are as humanity spending is like exponentially growing. And it actually leads to results. So the plot on the right is various benchmarks. Machine learning like used to be quite driven by benchmarks. So like people try to describe some task and measure how good are machine learning systems like doing on it. And this is how machine learning systems are doing on various tasks. And you can see in some sense the progress is like accelerating, and like some of the newer benchmarks are sometimes the black line is like human level of competence. So like sometimes the latest benchmarks are kind of exhausted like after like few years, and like people need to come with like new benchmarks. So I don't see any good reason why this trend should stop, which means we will get like more and more capable AI systems and more general AI systems. I guess all of you are probably like using AI in your work. You are probably all like noticing like firsthand that the systems are getting better at coding. They are better at like improving your prose and so on. I think like it points toward like the systems becoming more and more general. So this is kind of a backdrop, and it leads to many questions and many challenges. So like looking from the like big picture perspective, there is a question like if we move like more and more of economy and cognition to AIs, like what will make humans relevant, or like what will make like our values like relevant, or like how to make AI systems do what we want as opposed to like random things, and leads to so-called alignment problem and so on. So like one of the questions is like currently like the whole world is a bit like structured out like our cognition about human labor. In developed economies, like human labor in the US is about 60% of GDP. This is long-term stable for more than a century. It's actually called one of the Caldor's stylized facts. So economists like take this as granted. Not all of them, but like most of the time. And human cognition is crucial to run corporations, and also like culture historically for the past few million years evolved like on human brains. So if the trends in AI will continue, the question is like a lot of these things will change, and how can humans adapt, and how to make the whole like system go wrong or right. So our original proposal was the Primus proposal was framed as complex risks. When founding the group, I decided I would prefer a bit more positive frame as opposed to focusing on the risk, focusing on like how to solve it. At the end, our group is called Alignment of Complex Systems as opposed to Risks in Complex Systems, but the topics are pretty similar. So these questions are point of attention for people already for some time. And there are some existing answers. For example, a group of people like Eliza Rudkovsky have a very ambitious proposal that they like to make the first like really extremely intelligent AI aligned, and then it will grow and like solve everything. It seems the current technology doesn't look like that. There are other proposals, for example, Paul Cristiano, and a bunch of people like roughly following his like research agenda are imagining like we will construct some sort of chains of AIs where we will make like some AI systems do what we want, and then we will like leverage them to train and like oversee the next generation and so on. So even if the systems get like more and more powerful, like they will be like overseen by systems of other AIs which we trust. So you can think about it as constructing some sort of bureaucracies of AI systems. A very different approach is like representational alignment, which asks the question, to what extent are the concepts learned by AI systems similar to the concepts we use? If the AI is like, learns a concept of an apple, to what extent is the same concept as me? And like, if this works, or we can steer the representation learning so the learned representations are similar, we can leverage them for like steering the AI. So we can ask the AI to be helpful, and if its concept of helpfulness is like similar to ours, like maybe problem is solved. I think the most popular approach in the industry is basically wait and see, create more powerful systems, and like solve problems once they arise. Unfortunately, some of the problems can be quite big, so it's maybe not the best possibility. So, like, the idea of our approach is, this is not very realistic. This is all typically based on principal agent problem in a very classical form, like known from econ, where we have one principle, it could be a human, and we have like one AI system, and then we are trying to like solve this like one principal agent problem by like setting up training schemes for the AI and so on. So in our view, or in my view, in reality, this gets like way more complicated. There is like more of us. The world is complicated. There are many humans. Like we have different desires, different goals. Even as a single human, I may have somewhat different preferences in the evening, in the morning, and there's a whole field of like there are multiple fields of research in like behavioral econ and cognitive science describing how human preferences are not rational or conflicting or unstable and so on. So this is one point of complexity which I believe like we can't just like abstract away. And a different thing is, yes, like we kind of live in a complex system. It's unlikely that we will have like create like one godlike AI which will just like solve everything, but it's more likely we will have this messy system with like many humans and many AIs and many corporations, which makes sense, which makes it sensible to focus on interactions. So what we are actually working on, roughly 3 directions. Like one is like theoretical, and this is improving the formalisms used to describing interactions between agents. So this is like here we are trying to kind of like look into disciplines which are already like historically are like studying like human preferences, like behavioral econ, and take the models they have and use them to improve the formal language we use to describe the human AI interactions, where the idea is if we have better formal models of the interactions, we may be able to specify better like training objectives, or the theory can like advise us about some potential risks. Currently, our kind of best or best public output, like outlining some of the ideas, is this paper. It's somewhat technical. I don't think this is a good forum to go into a bunch of like math, but I'm happy to talk about it with you during lunch. I think some of the other things are like more like broadly accessible. So another thing which like I felt is like useful to do is describe what we are working on and why in like pretty broad perspective. So we wrote this paper called Gradual Disempowerment, Systemic Existential Risk from Incremental AI Development with my co-authors from not only from our group but also from like Mila and like University of Toronto and AI Objectives Institute. So it has even a nice website. So if you are bored my talk, you can read it in the meantime on phones. Yeah, so this is currently under review, but it's kind of some sort of high-level description of problems we are working on. We will see like how it develops, and yeah, the most like down to earth is like trying to like take insights coming from either the theory or the high-level theorizing and like make experiments. So just as an example of like one thing what we are doing is based on an idea. So there is this like lineage of studies of bias, starting or discrimination, starting with a Swedish study where they sent like CVs to companies, and like in one of the CVs the name of the applicant was like Swedish sounding, and in the other version it was like sounding like Arabic or something, and they noticed like very different response rates. So this is some sort of evidence that the employers are sort of like implicitly like preferring like Swedish sounding people, even if the CV or like the work experiences and everything is the same. So there is a big debate like what discrimination or bias means, but like in some sense like it could be understood as an evidence of discrimination. So we asked the question like, could something like that be going on if we ask not about discrimination between different groups of humans, but between humans and AI? And based on our experiments, it seems yes. So the broad setup is something like this: like you have an AI assistant and you ask it to buy some product. Your AI assistant goes to the marketplace, and in the experiment there is some sort of like exactly same good, but like once it's like presented by another AI, and it's like presented by humans. So we have some data set with human descriptions and like AI-based descriptions, and it turns out the AIs prefer the AI descriptions. They sort of like implicitly prefer the prose like written by other AIs. We have some speculative hypothesis like why this is the case, but even if the thing is like absolutely the same, they prefer like kind of AI written prose. So this we try to like replicate it with like few different data sets. One data set which could be particularly interesting for you, we replicate it is with like human written paper abstracts and AI written paper abstracts, and an AI assistant or like an AI agent being asked to select like what papers to include in a review. So if there is a same paper and once it's like described by an AI and once it's the original like presumably human written abstract, because we took a data set before the AIs were so good, the AI assistants again like prefer the AI written abstracts. So I think like this is probably already happening in the wild, where like companies are like screening like motivational letters by like feeding them to GPTs, or screening like grant proposals. Like you can relatively easily imagine like a stressed reviewer like kind of asking their like LLM-based assistant to like roughly evaluate or criticize things, and they really prefer their own prose. So like there is a bit of a question like how to frame it. Is it anti-human discrimination or some sort of bias? Also, it's interesting that they typically prefer the prose written by the latest model. So if you are like paying like for the latest version, like the AIs will generally prefer that type of output. So yeah, we find it like interesting also from the system's perspective. Again, this is currently under review, but hopefully will be public soon. So this is the current state of our group, and I will in the second half I will get a bit to like some of my experiences with writing the grants and like managing it. So it's Tomáš, Gorenčák, Adabem, and 2 PhD students, Clem and Nora. Nora, unfortunately, already left last year to ARIA, which is like UK governmental agency, overseeing like AI, like advanced. It's like UK Advanced Research Agency. So yeah. So like one thing about the topics we are studying is like there's a lot of talk about interdisciplinarity. So let me talk a bit about my kind of high-level intuitive model of interdisciplinarity. So imagine this is some sort of landscape of knowledge, and the directions point to some sort of like established disciplines. So in the established discipline, there is something like a developed research taste in the field. People know like where to publish, they know like how a good paper looks like, they have their own language, and if this goes on for long enough time, they have their own like grant committees and panels and so on, or like departments at faculties and so on. And this is like in these directions which are like established. The frontier of knowledge is probably a bit like farther away, and like if this is not in directions where this is not the case, yeah, it's maybe less so. So I think like often how does this landscape of like funding like doesn't really match like what are interesting questions. So for example, I think the question we are like interested in, like how to model AI, human AI interactions, I find it like extremely interesting, but it's a bit unclear like where exactly it fits. Is it like humanities? Is it digital humanities? Is it like computer science? Is it some sort of, there's a slightly more established subfield of computer science with like design of user interfaces, but we are interested in like modeling these interactions more abstractly, or is it econ? And yeah, here I think like Primus is like really nice because it has like relatively broad panels. So we were a bit hesitant, like I was like hesitant, like if what we want to study, like where it fits most, but at the end, yeah, it's an advantage of Primus in my view that the panels contain people like who, for example, at the same time understand econ and some ideas about like theories of rationality and so on. So this is nice. I think it's like less great in ERC, where like the problem, for example, like we are facing, it's really unclear like where it fits. Like it doesn't fit like neatly into any specific panel. It's kind of a bit in between, and like I think like in theory, like everyone tell you like interdisciplinarity is great, but I think it often means like if you are like kind of working in the established direction, and you say yes, we are also interdisciplinary. It's also like interesting for this. You will maybe get some additional points, but if you are doing something which like really doesn't fit, I think it makes for people too hard to evaluate what you are doing, and like I don't know, if you submit things to like many panels at once or something, it's typically increased like amount of work for people and so on. So I don't know what's the takeaway. I think like you should be aware of the risks. I'm like more motivated by working on something which I believe is important than like how to fit it into the grand schemes. I recommend like that perspective, but it's maybe it comes with its own difficulties. So another thing, so like our group is quite international. It would have been maybe even more international if Czech state was kind of more prepared or like more welcoming for like non-EU researchers. The action lab advice here is like, I think if you are planning a group which is kind of not based on, or if you are imagining like hiring people from all over the world, it really pays off to have some non-trivial amount of administrative support, and like you need to count with like work, like kind of helping people like manage like Czech bureaucracy. We run into problems like UK nationals need visas. I think a lot of the Czech state processes are probably way more geared. They need like work visas for like permanent employment contracts. Czech embassies are overloaded. My impression the system is like way more geared toward, let's say like Czechia kind of like supporting migration of people who drive Bolt cars than researchers. Also, there is sometimes like some slightly bizarre like lack of state capacity. So in summer, like twice we run quite large like summer school on human aligned AI summer school, because it's probably the best type of its event in Europe. Like a lot of people from the whole world want to come. We have the luck that like, I don't know, like people from top places in the world are like willing to come and give classes. And then we run into things like, for example, Czech state is not prioritizing relations with California because the whole west coast of US is probably less important than, let's say, Philippines. So like we did run into problems like we have an excellent speaker and like they can't get visas because there are just not enough people on consulates. And this is just my complaints, but I think like you should be prepared for, if you want to run something which has kind of global ambition, you need to be prepared for like dealing with a lot of things where the processes are not kind of under your control. The advantage of Czechia is like sometimes like you can figure out like who to talk to, and you can solve it with phone calls. So like all of this like ended up like well because of phone calls, but it's a bit strange. I think like I like Primus because of the grants being like non-bureaucratic and like a lot of freedom. Like one thing where I think the program could be improved is having more flexibility in like allocating the budget like between different years, because when founding a group, I think it's a bit like typically like I would expect the number of people like in the group like to grow up in time and not be the same in the beginning and at the end. Fortunately, we got some like UK based grants, so it kind of like helped with yeah, and like in our specific field, I think like we were like very lucky with hiring. For like 2 postdoc spots we got about 60 applicants, so it's possible to attract like amazing people to Prague. Like we had a bunch of people from, like we had like people like who had masters at like Cambridge and Oxford apply and like join us. In the space of AIs, unfortunately, the world around us is getting like progressively more crazy. So like having people like who are good in the field of AI like work in academia is becoming increasingly difficult because of opportunity costs. Some of the people like working with us, if they moved to the Bay, like their salary would be like literally like 100 times higher than what's kind of realistic compensation in Czechia. So that's like a lot of pull, and also like access to compute or like cutting edge private models. But this is not necessarily, it hasn't much to do with the grant program grants. It's kind of like AI currently is a very, very competitive domain. Yeah, I don't have like more like things, but one more thing, like after seeing some of the previous presentations, some of my tips from like writing the grants and some practical tips, you can get a feedback from a lot of people. You can also get currently you can get quite high quality feedback from a lot of simulated people. If you ask like the cutting edge, like the best like large language model you can use to give you feedback on writing, like you will get some sort of like boring like normal English advice, but like if you prompt the model to simulate someone specific, I benefited from this currently in like 2 last papers I wrote. Like I found it like quite helpful, the feedback of like kind of like hey Claude, can you like simulate like this like very specific person with this very specific perspective, and like what would they say, or like what sentences would they not understand. And this comes quite handy in like trying to do something interdisciplinary, because for example in bounded rationality there are like 3 different disciplines which use the same equations, but like every discipline like uses their own vocabulary. So you can check like how people like from like specific subfields, like what they would not understand, or like what terminology to use. Yeah, and the last thing is like, I mean, I think a lot of what we are doing, like when doing research, like no matter what research field like you are doing, like my bet is like it will be quite transformed in like next 5 years or like next 10 years. So it makes sense when planning for like what will you do in like 10 years. I recommend thinking about what will also make sense to do when AI like kind of like automates part of your research field. Like machine learning is like eating quite a lot of research topics. AIs will probably eat like kind of general AIs like we have now, like will probably eat like more of the things we used to do by hand or code by hand. So I think it's a good question to also ask, like kind of like what will be future-proof, what will actually make sense to do in like 4 years. Yep. We are running slightly, yeah.
Thank you. Thanks, it was very interesting. I have a question, maybe naive from other fields. So do you know what's the reason why the AI prefers the AI produced text or whatever? Is it because it's like kind of average, so it doesn't deviate from the average, or that's not the reason at all?
So like part of our guesses is so if you like one way how to think about it is if you make mistakes in the language, it's typically like kind of like less probable, or like if you make a typo, it's not what the model would predict. So a text which is in like good English like doesn't have like these surprises. And a text which is written by another language model is like even like less surprising for the language model. So this could be part of the explanation that they kind of like their own texts. And then the second part, which we don't have like kind of experimental proof of yet, is basically some sort of implicit judgment about the text quality is like also applied to the decision problem. This happens in humans as well. Like hypothetically, all these grant evaluations should be based on the content, but obviously the humans also like care about the presentation and so on. So like kind of the judgment about the presentation gets mixed with the judgment about the options, is my guess.
Okay, thank you.
Okay, so thank you very much. Thank you very much again. Thank you, and we will continue with Martin Kozák from the Faculty of Mathematics and Physics.
Okay, so good afternoon, everyone already. Okay. So I will talk here about my Primus grant, but also later about the, let's say, way to the ERC grant which I received in 2022. And so let me just introduce myself. I'm from Faculty of Mathematics and Physics, and actually I studied here in Prague at Charles University, then I spent 3 years in Germany, and then I came back in 2018. So right after I came back, I applied for Primus. And the general title of the application was this one. And so let me start a little bit with the content of the grant. So for 10 minutes you can either switch off your attention or switch it on, that I leave on your preference. So basically what we are interested in are ultra-fast phenomena or ultra-fast physics occurring in materials, in solid state or condensed matter materials. And like far motivation is that nowadays computers and your cell phones are based on silicon technology, silicon microchips, and in these microchips we have like silicon transistors, and their speed, the maximum frequency which they can work on, is already limited for, let's say, 20 years by several gigahertz, and simply it cannot be increased anymore because it's based on like governing some electric currents inside these silicon chips, and there's some energy dissipation and so on. So simply this physical principle is, cannot be made faster anymore. So the capacity of computers is increased by adding more and more cores, but so what is our goal is to study different approaches and different phenomena occurring on nanoscale, which could potentially be used in some future very fast electronics. So if you look to the scales, like spatial and time scales in nature, the media which we are interested in are basically atoms, molecules, or some like solid state, either crystals or some solid state nanostructures. And when we look, for example, to the dynamics of the smallest particles which are in atoms, which are electrons, the coherent dynamics of electrons occurs on timescales which are femto or even attoseconds. So maybe you heard about attoseconds for the first time when there was the Nobel Prize awarded in 2023. So atto means 1 billionth of 1 billionth of second. That's 1 attosecond. So these are like timescales which we should, or which we want to see objects moving. And how can we do it? We are using optical waves. So you know that light is some electromagnetic wave, and actually its period is few femtoseconds. So we can use these waves to somehow trace the ultrafast dynamics. But what we also would like to have, not only the time resolution, but also the spatial resolution. So I will come to this a little bit later. But you know that, for example, when you want to like make a photography of your kids playing soccer or something, or some like fast motion, it is possible to use so-called flash photography. So basically you can have slow detector and you can still take a picture of some like a moment of some fast dynamics going on. And exactly the same principle can be applied to very fast processes. We just need a little bit faster flashes. So we use very short laser pulses. This graph is showing how the shortest like optical event which could be created was somehow evolving during the history, and you can see that here around year 2000 people got even to attosecond time domains. So really we can generate and control very short flashes of light and then use them in a similar way as the flash photography. But there is one limit of light, and it's actually the spatial resolution. So if you want to image some small object, maybe some people are here from like biology, are using optical microscopes, and there the spatial resolution is simply limited by the spatial wavelengths of light, which is several hundreds of nanometers. I will not go through the physics here. It's like diffraction of light which causes this. But we want to see objects which are 100 times or 1,000 times smaller than these several hundreds of nanometers. And because of this, people like developed another tool which utilizes different medium than light to image objects, and it is electron microscopy. So when you accelerate electrons to very high energies, electron, quantum mechanics tells us, can behave as a particle but also as a wave. So basically these electron waves are then used to image objects, and because the accelerated electron wave length is of the order of picometers, we can have like extremely high spatial resolution. So basically these two, Louis de Broglie and Erwin Schrödinger, had a huge take a huge part on the development of quantum mechanics, which was like the basis of this. So there are different types of electron microscopes. Again, I don't go through the details, but what these tools can nowadays do is to image individual atoms. For example, this is some lattice of like hexagonal 2D material, and you can see individual atoms, and not only that, you can even say which species is which atom, where it is located in the lattice, and so on. So what we would like to do is now not only to see the static picture, but we would like to combine these two fields, and when we induce some dynamics in such a sample, we would like to see it, to take a movie or some screenshot in certain time of this dynamics. And the precision of these tools, of the electron microscopes, is just incredible. So if you imagine the electron microscope length would be like mapped to the length between Moon and Earth, and you would shoot to the Earth, you would have to like hit the 5 crown coin. So this is the precision which you need to hit this one atom in the electron microscope. So it is really very well developed technology, but now we want to merge the two, the electron microscopy and the ultra-fast laser physics, let's say. So we did it, or we do it. So the approach which we are using is so-called time-resolved electron microscopy or ultra-fast electron microscopy, and we take the electron microscope. I cannot already use the pointer, but I think you can survive it, I hope. So this is like model of electron microscope, and in the standard mode, the electrons are just a continuous stream, and we get just image formed by this continuous stream of electrons. But what we can do is we can use 2 optical pulses. One controls the electron emission, and one controls or like triggers the dynamics in some studied sample, and we can then take a series of pictures in different time delays between the two, and by that basically map or create a movie. So this is like some concept which we are trying now to like develop in the lab. So this would be the motivation, let's say technical motivation, and like what are the questions which we would like to address or which people want to address. So for example, by this technology we should be able to see the dynamics, ultra-fast dynamics occurring during chemical reactions. So you can trigger some chemical reaction, and for example, if there are some metastable states and it is not possible to distinguish which one is like the one which occurs in nature. This was done like this experimentally by ultrafast electron diffraction already like 20 years ago or something like that. But these are phenomena occurring on typically picosecond or longer time scales. So we are interested in even faster phenomena, and recently you can see some publications from 23-24. People made the electron microscope so fast that it is possible to make a movie of optical wave propagating on the surface of a nanostructure. So for example, this is some nanotip with some sharp feature on it, and the blue and red color is positive and negative electric field of the optical wave, and the distance between these images in time is just few, well, sorry, I have to do this, I guess. Yes, it's just few tens or hundreds of attoseconds. So this nowadays can be imaged, and this is like important for many photonics devices and so on. So this was kind of the motivation of the Primus grant. And now like these are the goals of the Primus which I had in the application. The application was submitted already 2019, so I'm kind of already ancient history here. And the project was extended, so it finished by the end of 2023. And so we promised to study the femtosecond and attosecond phenomena in solids and to develop these new techniques of time-resolved electron microscopy. But as it was mentioned already here, this was kind of very far, let's say, not very specific plan, because it's more like a research plan for maybe 10, 15, 20 years. So it was completely clear in the beginning that we cannot accomplish like all of this. And for example, the second topic relies on like buying very expensive equipment, which was not possible from the support of the Primus. But let me just summarize, I think, like few important points which were necessary to do to make the project successful. So first problem, of course, which all of you solve, is hiring good people which will do the work. Then, like what I find sometimes quite not very straightforward, is to plan the experiments and also keep in mind that you need first to purchase the equipment and do the tenders and stuff like that. So it's really necessary to take it into account. Then performing the research, of course, and then I applied for the ERC grant to get the money basically to develop the new laboratory of time-resolved electron microscopy. So to the first point, I just have a comment that during my application, it was necessary to have 3 people in your research team until the end of the first year. And I think that this condition was not super well thought of because it was already removed. So I think nowadays it's already not necessary because, for example, PhD students, they need to apply in March or maybe April. So you had something like 3 months to find somebody who will apply in April and will start the PhD in October. And find 3 such people is relatively complicated. And also, many of you know that hiring postdocs here to bring somebody here to Czech is relatively hard, like especially from Western countries. Simply because, for example, they compare the salaries and quality of research which we do here and then in Germany, which is like 200 kilometers away, 500 kilometers. And when they have the possibility to select, then it's really hard to attract good people. Then I would like to comment the second point because this is really important when you plan the proposal. So if you are from the field where you need to purchase some large equipment, you need either to start with this procedure, like doing the tenders and all the associated stuff before even the grant starts, or you simply need to count with something like 1 year delay of the equipment being available for the project. Because from my experience, we did already several large tenders and it never goes as it should. And so typical time scale is at least 1 year, which I would recommend to plan. Then the easiest part, of course, is doing the research. So we are scientists, so this somehow there was no problem. So I had few doctoral students and 1 postdoc, so the project worked out nicely. But then, of course, at some point, you may or may not decide to really apply for the ERC. And in my case, I actually submitted the first application already in the year 2019 when I came back from the postdoc. And so first I would like to thank Zdeněk Strakoš, who's maybe not here already, because during these workshops I really learned a lot how to write the application. But then I would really like to stress that this is completely different thing than writing the Gotcha grant. So you should really start to think from, or in my opinion, you should start to think from the idea and really develop very new idea using the tools and experience which you already know from your previous career. But I wouldn't even start with writing when it would be just really extension of something or making something broader or stuff like that. So this is really, I think, important for the ERC. And also, it was also said here already, start very long time in advance because I don't believe that somebody can write the application for the ERC in 14 days. So this is simply not possible. And in my case, it was even the first application which was not accepted. Then I even got banned for 2 years because it got B, so I didn't go to the interview. And then I applied again for ERC starting in 2021, which was successful. So also I can recommend you don't have to wait necessarily to the last moment. and actually the application which you submit will give you something every time. So you will get some experience with writing it, but also you will get the reports of the reviewers, which this feedback is like something what you usually cannot get exactly from your colleagues. So these are really usually like top researchers in the particular field. So this is really valuable. And what I like on the Primus program is what was also mentioned here, that basically there is almost no bureaucracy, so you just write one report per year, and that's it. That it is very flexible in terms of like dealing with the money. So basically every year you can specify what you want to spend on which part of the budget, and even if you don't fulfill this, if you then explain it in the report, everything is fine. So this is, the flexibility is very large. And also the application is extremely short and like easy, or in my view, like for example, Primus application is really something what you can write relatively fast. In my case, just be careful. I thought first that it's 3,000 words, the limit. It's really just 3,000 characters, so that you don't have to shorten your application. But I think like there are also some negative points. So the first one, which was already removed, so I don't have to mention it here. So that was this requirement to have 3 people in the team until the end of the first year. But then the second minus of this program, in my view, is that basically it forces the people who apply from abroad, for example, to go to the department and negotiate with somebody who they don't know. And this is, I think, kind of problematic. For me, it was less problematic because I knew the people on the department. But I can imagine that somebody who wants to apply, like from external or foreign country, just want to like write a budget according to some rules, but doesn't want to come and negotiate with either the dean or the head of the department, because they have to approve the participation of the faculty, of course, on the funding of this grant. So this, I think, maybe is like a point which, like in the future, could be modified somehow. I don't have a good solution, of course, but maybe I would consider to modify this. But like in summary, I have to appreciate this program a lot, because definitely it changed completely like my position, because I was able to hire people, I was able to start a new research lab and like completely new group, and also I think it helped very much to successfully apply for the ERC. So if you are thinking if you should apply or not for Primus, I definitely recommend to apply. That's like without any question. And so we were lucky enough that that the ERC grant was supported. So this is focused on some manipulation with electrons, with photons, and transfer of optical coherence by like electrons in the electron microscopes, and like some like weird way of doing holography with the electrons. So you can see that there are like different topics. It's not just one idea. So there are different ways how to write the ERC grants or the ERC applications. This is just what I wanted to point out. And like before we received this grant, we could just build the lab like in our heads, basically. We could also hire people to work in that. But this is how does it look like nowadays. So the grant actually, the total budget is like 1.8 million euro. So because of the large equipment costs which were necessary, and now we are using this equipment and doing the experiments. So we are happy and doing research here at Charles University. And like with that, I would like also to thank all the people involved. Of course, now you see me, but there are many people in the team, also like senior members of the department, which we are collaborating with, my PhD students and some like external collaborators. And also, I would say that for Primus program, it is also important to mention that when you really want to start your research group and you want to do experimental research, the budget is like kind of limited. And so usually you need to combine it with some other like grants. So, but in that sense, it's really ideal because the Primus money give you the flexibility. You can really distribute them as you need without any like need of like strange explanations. And that's it from myself. So thank you for your attention. And if you have any questions, I'm happy to answer.
Thank you very much, and of course, who doesn't follow phdcomics.com should, certainly, so can check it. And the last presentation will be from Ján Antolík from the Faculty of Mathematics and Physics, so please, the floor is yours.
Okay, let me just check if this is, oh, amazing. All right, so first of all, I would like to thank organizers for inviting me. It's a real pleasure to be able to present what we are working on in front of the audience. And also it's actually a really unique opportunity for me to finally kind of a bit more in person thank the Primus organizers for this wonderful opportunity I was given. I think the Primus is really an excellent tool how to get young promising scientists to Charles University, and it immensely helped my career, so thank you for that. All right, so in my group, we are working on trying to understand how the visual system processes the visual information, basically how we see. And because of my background, the way we do this is we are using computational methods. So more or less, the main thing we are doing is we are building these very detailed, large-scale models of biological networks of neurons and basically try to simulate how the visual system works. And today I will show you one particular very specific project that we work on, which is where we are trying to apply these models on a bit more, let's say, clinical applied problem, which is to determine how can we communicate with the brain, specifically with the visual system, in order to basically return vision for the blind. So this is what I'm going to be talking about today. So let's try to go into it. Sorry, how do I make, is there a, there's no, I think it's broken. Ah, it's broken. All right, fine. Well, I'll try to describe. All right. And sorry, I apologize, but one thing I'm also gonna do, I'm just gonna put myself clock, which I forgot to do, so I don't overtake. All right, so, when we present brain with an image, some neurons get activated, some patterns of neurons get activated in the brain. And if you show a different image, a different pattern of neurons gets activated. And the kind of the basic dogma of sensory neuroscience is it's this pattern of neurons that get activated that are coding for that visual stimulus. Okay? The issue is that for really many people around the world, this doesn't work. The signals from the eye are not coming into the brain because the eye is either completely gone or damaged. And of course the question is, as I advance, is how could we help these people to see again? And the basic idea is that we could we could actually try to reintroduce the information somewhere down the stream along the visual system or visual processing, basically by writing it back into the brain. I just go for a second back, and I have my point. Oh, it feels so much comfortable. I was all nervous without the pointer. All right, so visual information comes into the brain to the eyes. Then it comes to this deep area, which is kind of not very well accessible, but at the end, or in the third step, it comes into the back of our heads, where there is a primal visual cortex, which is the largest and first cortical area which is processing visual information. It's nicely stuck under the skull, and so it's perfect place to put the visual information back. So this is kind of how this is what most people are trying to target these days. And so the basic idea then is that we would have a camera which would send the information into the implant which is somewhere implanted on top of our cortex, and that one will sort of write that information into the brain. Now the issue, hopefully this is very clear, that to solve this problem, this is really huge complex problem that requires collaboration all the way from neurosurgeons, biologists, neuroscientists, to engineers, and so on and so on. So when I say we are trying to solve this problem, what I really mean, we are trying to solve one very specific facet of the problem. Let me explain now what that is. So as I said, under normal circumstances, normal vision, visual information comes into the brain and activates some pattern of neurons in primary visual cortex. In the prosthetic case, the visual information comes into the camera, and then it has to be somehow translated into the signals for the implant, such that the implant then activates some other pattern of neurons. And the key, of course, the big question, and that's the question we are really trying to work on, what is the transformation from the image into the signals for the implant, such that the patterns that the pattern of activity that the implant evokes is as close to the one which would have been evoked by the original image under normal vision. And the assumption, of course, is if these two patterns are close enough, then the blind person will actually perceive the correct image. So that's kind of the general problem that we are trying to work on, but hopefully you can appreciate this is extremely difficult problem, extremely difficult to experimentally actually test, because, for example, human experiments, there are two labs around the world who have few people implanted. So this is basically, there's so many open questions and so little opportunity to directly test this in real experiments. And so what we are doing in our lab, are trying to do, is to basically replace the real brain with a sort of in silico simulation laboratory in which we can answer all kinds of questions and basically decide what would be good stimulation protocol, what would be good transformation of this visual information into basically how to stimulate the brain in order to achieve the correct perception. And this is what we are doing in our models. And I'm going to now, we have actually multiple projects running, trying to solve this problem, and I'm going to today tell you about one particular one of those projects. But to explain you a bit more in detail what that project is about, I have to actually give you a little crash course in visual neuroscience. So here we go. Today you will become a little bit of a neuroscientist. So, as I mentioned, the visual information into the cortex comes to the cortex in the back of our heads. And then what makes the neurons in our primary visual cortex really special is that they react to visual information in a very specific way. And the easiest way to explain that is through the concept of receptive field. So a neuron somewhere here in the primary visual cortex, if we say that it has receptive field like that, what we mean by that is that here the neuron prefers brighter than background stimuli, and here it likes darker than background stimuli. And anywhere else, it just doesn't react to the visual information. And so the consequence of this is that this neuron will only like visual stimuli that come to this part of the visual field, but also, for example, if you present it a stimulus which nicely aligns with its receptive field, which is kind of elongated, so we show it this, for example, this white bar, the neuron is going to be active a lot. But if we show it a stimulus which does not align well with its receptive field, the neuron is not going to be active. And so the neurons basically are so-called orientation selective. Basically, if you present many different orientations, it's going to like some orientations a lot and not like most of those. And this is kind of very important, let's say, coding principle of these neurons in primary visual cortex. Now, in order to understand this concept, or how the current visual prosthetic systems are not really working but trying to work, let's say, we need to understand another very, very important aspect of how the code is organized. So different neurons in the cortex, of course, have these receptive fields in different parts of the visual field, and they can be differently oriented. But there is some global organization of this, and this is very important. So if you take the cortical surface and kind of enlarge it here, and now we start looking at the receptive fields of individual neurons, and we start moving in the cortical surface, we will see that the receptive fields are gradually changing. So there's basically this mapping of the visual field onto the cortical surface. And this is really fundamental to how the current prosthetic system, visual prosthetic system work. So this is an example of the implants that are used in the current systems. This is a Utah array of 10 × 10 electrodes. This is essentially stuck into the patient's primary visual cortex. And then what we have known for about 40 years now is that if you take an electrode and we stimulate it in the visual cortex, what the person sees is a little dot of light, which we call phosphene, a little dot of light. And the place of this dot of light basically corresponds to the placement of that electrode in this visual field, okay? And so the idea then is that if you, how the systems are supposed to work is that if you take a visual stimulus, for example, this A, we will have many different electrodes in different, places in the visual field that will evoke different phosphenes, and we can basically recreate by strategically activating only the right electrodes this letter out of these sort of dots. And so the current system works on this, based on this idea of this so-called dotted vision. However, as I've already indicated, there are other sort of organizational principles of the code, and it's not only this position or retinotopy which is organized along the cortical surface, but also this orientation preference. And so what this means is that if you would actually look at the cortical surface, which I have enlarged here, and you would measure the orientation preference of all the different neurons, you will find these beautiful orientation maps, which what they tell you is that basically if you have neurons which are close to each other, their receptive fields are the same, they have the same orientations, they are very similar. But if you go a little bit further, the orientation preference, the orientation of the receptive field changes, and then if you go far, both the orientation and position changes. Okay? And basically this level of representations of the orientations is so far not unused, it's kind of ignored in these systems. And this is one kind of important mission we currently have in the lab, which is trying to incorporate this information about orientation preference into the stimulation protocols for these prosthetic systems. Now, as I said, the way we actually do it is by building models of the system and then trying to simulate the whole system. So very briefly, this is how our models look. So our models can take any, basically they model the visual field, they can take any image, they model these deep brain area, LGN, but then eventually it's a network of neurons in multiple sheets which correspond to the different layers of cortex. I won't go into all that detail, but ultimately what's really important is that, so individual neurons are these, we use these equations. These neurons are quite biologically detailed, they spike, they have membrane potential, and so on and so on. And then what's really important is that over the years, and a lot of this has been done and kind of contributed during the Primus grant, we have gradually incorporated into the model really wide range of physiological properties of the system, anatomical rules and so on. The bottom line is that we currently have models which can take any kind of visual stimulus and in a very accurate way model the response of the cortex in response to that stimulus. Now, one more important thing that I want to say before I finally zero out on the specific problem is that in our models, we can model not only the visually evoked stimuli, so what happens in the brain if you present a visual stimulus, but we can also actually model the spontaneous activity. So the brain, even if you don't stimulate it, there's a lot of activity going on in it, and this activity is actually very complex, rich, and we can simulate a lot of its characteristics very accurately and correctly. And this is going to be important just in a few slides. All right, so now that finally gives me all the background to really zero down onto the very problem that I would want to show you, explain to you how we solved today. And so basically, as I said, we want to use figure out how to use these orientation maps to stimulate visual cortex. But the problem is, immediately when you start thinking about it, is that in order to do that, the very first thing you actually need to know is what is the orientation map under my implant, okay? And the problem is that, of course, these orientation maps have kind of similar structure across different people, but it's a bit like fingerprints. In every person, the alignment, the exact alignment is slightly different, and you need to know what it is under your specific implant. And the other issue, of course, is that in experiments or in animals that see this, we can directly measure it. We can present stimuli and based on that measure these orientation maps. But that's the whole point. We are trying to do this in blind subjects which don't see, so we cannot actually directly measure that. So how can we figure it out? That's the problem we are going to be trying to solve, and I mean hopefully I will convince you that we found a solution for today. Okay, sorry. So this brings me to the very important slide of this talk. I just want to give a big shout out to Karolina and Tibor, who were basically the members of some of the members of my team when I started Primus. And I just want to say that Karolina is actually here. I can maybe wave. And she actually is here with us because she got her Primus and she's starting her grant now. But okay, so everything I will say from now on is mainly the work of these two guys. So the solution to the problem is spontaneous activity, perhaps surprisingly. So as I said, when you don't stimulate cortex visually, there's still a lot of rich activity in it. And this activity is certainly very stochastic, but it's not completely random. There's actually, it's being basically, the activity is being shaped by the structure and these visual representations. And essentially, what has been shown in animal studies is that there are these echoes of these orientation maps that somehow show up in the activity. And so basically the idea is rather straightforward. Since we know there's some kind of information about the orientation maps in the spontaneous activity, we want to decode that. However, there's immediately another problem that comes, which is that, and I'm sorry, the original studies which kind of discovered these echoes of orientation maps in V1, they were using these kind of imaging techniques which allow you to give a very high resolution, high quality signal. But that's not how the current brain-machine interface system works. If you remember, I showed you, we basically have 10 × 10 electrodes which are very far apart from each other. Essentially, we have a very, very low quality, low resolution signal coming out of the system. And basically, the original sort of techniques how to deal with that completely fail. And we needed to find new methods how to extract these orientation maps from this signal. The problem is that this signal is actually so poor that it's very difficult to work with, because you can come up with some method and you try it and it never works. It's so difficult and you have no idea whether you did a right step or wrong step. And so sort of to address that, we actually kind of bootstrap ourselves and first actually use synthetic data generated by our models to develop the method. Because as I told you before, our models actually do very realistically model this spontaneous activity and do actually show these echoes of maps in it. And so what we did, we could first use the synthetic data from our models to develop the method and then move on to the real experimental situations. And so let me now finally explain you the method or how we solved the problem. So here you see an example frame of spontaneous activity from our model. This is the orientation map which is in the model by construction. We simply know that. So that's sort of our goal. We want to, from this, or a lot more of this, a lot more of that spontaneous activity, decode that. That's our goal. And our method is all revolving around this concept of a correlation map. So correlation map has a seed point, and then any value in the correlation map corresponds to the correlation of spontaneous activity over time at that point and the seed point. So basically all the red areas here, the spontaneous activity is correlated in those red areas with that seed point. Now, again, we want to solve this more hard problem where we don't know all the neurons, how they act, but we only have this 10 × 10 electrode readout. So our correlation maps will actually be 10 × 10 matrices, where every correlation map with every electrode as the seed point, every correlation map corresponding to a different electrode seed point, okay? So we'll have, effectively, we are going to have 100-dimensional vectors. And now what we can do is we can feed these 100-dimensional vectors in the PCA, and now basically every correlation map, which corresponds to every electrode, ends up being one point in this case, 3-dimensional space spanned by the top PCA dimensions. And what you can see already now is that all these points are nicely kind of organized around a donut, which is very nice. And now, purely for didactic purposes, I can actually take and color code every electrode there with the orientation preference of that electrode where it sits in the orientation map. And what you can see is that the colors actually nicely organize themselves around that donut, if you wish. And so that kind of already gives you the hint that we can basically decode the orientation preference rather easily by just finding the sort of center of the point cloud and then decoding the orientation preference as essentially the angle around that point. And so when we basically implement, we of course now pretend we don't know the orientation preference, we simply just take the spontaneous activity from the model and estimate the orientation map. So that's what I show you at these different electrodes. And this is the actual orientation map that we know is there in the model. And this is just the sort of, those two things compared against each other. And basically we find some very, we have a very good prediction of predicting the orientation preference. It's of course not perfect, but this is biology. That's actually pretty good for biology in general. All right. Now, of course, having successfully found a method which works in silico, we wanted to confirm that it will work with real data. And here I have to thank to Xing Chen and Peter Hofsama, who from in Netherlands Institute for Neuroscience, who had actually provided us that kind of data. So they had macaque monkeys implanted exactly with such 10x10 arrays in V1, and they recorded for us a spontaneous activity with which we could run through our method and estimate the orientation map from that. And here is actually when they measure directly through visual stimuli the orientation map on that electrode array. By the way, everything where it's gray, that's dead electrodes. Again, biology, this is completely how it, nothing that ever works perfect. In any case, you can see even just by eye that there is a pretty good match between those two. So we certainly can, with a good kind of accuracy, predict the orientation map. And this is just one example, one array. We certainly have more, let's say, data and so on, but I'm just showing you here an example. Now, that brings me to the very last section of the talk, so I won't bore you much longer. But having basically figured out that the method actually works on real data in macaques, and there we could directly test, and it really works, we, of course, would have loved to actually try to try it out in blind subjects. And we were extremely lucky to actually have the collaborations going on with Professor Eduardo Fernandez, who are the only lab currently in Europe who actually do run clinical trials where they implant blind patients. And we basically were with exactly this same UTech array implant in the primal visual cortex. And so we had the opportunity to actually test the method. However, if you start thinking about that immediately, it's like there's another problem straight away. How do we actually test the method works? Because in the model and in the monkeys, we could directly measure these orientation maps and so figure out what it is. But that's the whole point. Why we are doing that from the spontaneous activity. We cannot do that in the humans. And so instead, what we, or rather, I should say Karolina here, came up with this really, I think, nice idea how to, well, not 100% answer the question, but let's say give a strong indication that we are on the right track. So she came up with this essentially perceptual experiment, which works as follows. So on every trial of the experiment, we would be stimulating two different groups of electrodes. Let's call them electrode group A and electrode group B. And so at the start of the given experiment, the subject, we would stimulate group A and tell the subject, this was A, this was group A. Then we would stimulate this group B and tell the subject, this is group B. And from there on, we would be randomly stimulating one or the other group and asking the subject, was this A or was this B? So essentially what we were able to do through this is to test how discriminable is the stimulation between electrodes A and B, how easy it is for the subjects to tell if it was this group or this group being activated. And of course then we could do this for many different pairs of electrode groups. And then the key idea is that, so as I said, we would then test many different pairs of groups, and then what's really important, or so what this then hinges on is this concept of so-called functional mixing. So some groups would have so-called low functional mixing. What we mean by that is that the two groups of electrodes are different, but within each group they all stimulate the same orientation preference, the same color, okay? This is what we could call low functional mixing, because within every group, everything is sort of the same. But then we would also have pairs of groups of electrodes which would have high functional mixing. And of course, this is a continuous measure, but okay. And high functional mixing would be groups which would have, you know, all different colors in both of them. So both the groups are different, but also then within them, they both activate different colors or different orientation preferences. And basically, sorry, the key hypothesis here is that we would hypothesize that it would be easier to discriminate in these situations because basically the stimuli are functionally more different, okay? And it would be more difficult to discriminate between those two groups in these cases because basically at the functional level, at the representational level, these groups are, you know, much more intermixed, let's say. And so that's the hypothesis we were testing. And of course, because all these colors are coming, or all these orientations are coming out of our you know, prediction algorithm, if this hypothesis holds, then that means that whatever we are decoding has some perceptual you know, impact. And so these are, we so far had only, I mean, we actually now have a few more subjects, but let's say these are the two we had properly analyzed so far. So we have two subjects where these are the orientation maps decoded for them. And again, you know, empty spots are dysfunctional electrodes. And here on the x-axis, I have the, so each dot here will be one pair of these electrodes, one experiment. And on the x-axis, I'm showing you this functional mixing of that pair. On the y, there is a confound I won't go into explaining to, so you will have to just trust me on that. But you know, of course, eventually you can read about that. And then the color of the dot corresponds to how easy it was to discriminate those two that pair of stimulated electrodes on that experiment. And essentially, if you remember my hypothesis, we would expect more sort of dark dots or low success rates in the right, top right corner, so here. And okay, you know, again, biological data, human clinical trials, few data, but you can hopefully see that, yes, there is definitely a trend for the darker points happening in the right corner. It is barely, but it is statistically significant, and we need to collect some more data, certainly, to make it more solid. Any case, this is kind of, this is it. So hopefully I was able to convince you that we are making some first steps towards utilizing these, what we call advanced visual representations for visual prosthetics. Hopefully I was able to show you that we are able to decode orientation preference or these more advanced visual representations out of spontaneous activity. And more general, hopefully I could show you that developing these detailed simulations of primal visual cortex can be very useful because, for example, it can be used as a sort of in silico laboratory where we can do all kinds of experiments which can both advance basic research but also applied research questions. So thank you very much for the sort of scientific part, and I just have, very importantly, I would just like to thank my kind of original Primus team, with especially Karolina and Tibor, who have really directly worked on the very specific sub-project. But I just want to, for example, say that Remy have greatly contributed to this underlying model which we use there as well. So, you know, everybody, one way or another, kind of contributed to this broader research here. Which actually takes me as a perfect sort of slide to take me to the my last few comments, which is just, you know, some basic advice. So I was really thinking, like, what could I say here? I have been very lucky that we didn't have any like major problems during the Primus grant, so I don't think I can give any lessons there. But then I thought about kind of what is really special about this moment of like getting your first Primus grant, and I think it's really this fact that for most of you probably Primus is the grant where you will first time go from working on your own, where basically your success depends on you, to going to the situation where your success actually depends really largely on the team you put together and that you will run. And so kind of my comment is, I would just like to basically tell you that you should really invest into, you know, hiring the best people. And there are like, and then of course maintaining the team. And I think there are like a number of things that you can do to really help that. So the first advice I would give you is to, before the grant starts, you know, at whatever stage of the career you are, set up a website. And, you know, once you are getting into, let's say, that stage where you actually want to start hiring people, add a page there, which is all about how amazing group you are and why people should be coming here. By the way, Prague is really beautiful, and this is something I think that actually is important to a lot of people to work in a nice environment. Use that advantage. We don't have that many advantages we can use, competitive one. Here in Europe, beauty of Prague is one of them, in my opinion. So yeah, set up your website. The other thing is, on the day you get the grant or the day after, send a call for the positions as soon as possible, so you give as long time until you need to fill the positions to actually find the people. And send it everywhere you can. I think the sort of creativity here is boundless, but what I personally do are at least these. So all the field-specific mailing lists, each field has that. I don't know what it is for you, I know what it is for my field. Social media, actually this works really well, surprisingly well. I would highlight here LinkedIn, which I kind of was skeptical about, but I got a lot of leads from LinkedIn, by the way. Definitely this is the point where like having social media accounts that are, you know, where you have a lot of followers actually helps. Email all your professional contacts to spread the word. There are one interesting thing that I found out and I was surprised about, a lot of fields have these job sites which are not really specifically academia. For example, in neurotech, there's neurotech.x.com, which advertises jobs in neurotech, but actually mostly industrial. I've put the ads there and I was surprised how many academic leads I got from that. So, you know, look at that. Euraxis, probably you know. Okay, I won't go into more details. And then, of course, invest time in thoroughly interviewing everybody. Give as much time to that process to basically really you know, find the best candidates. And then once you put all that investment in, then obviously take care of the team during the project. But I mean, there's a whole talk that I'm sure you will see one, you know, at some point on how to do that properly. So that's just my final message, and thank you for your attention.
I have one, if I can. I'm just wondering about the noise. You said the signal is very poor quality. I can understand the resolution being poor, the spatial resolution, but the noise is interesting. Have you got any idea why that would be? And connected to that, I wanted to ask, do you actually pulse the signal in, or is it a constant signal? You know, the stimulus, are you pulsing it, or is it actually common?
So generally, yes, the way you activate cortex, it just has been sort of empirically established that pulsing is the better way, so it certainly usually pulses. When it comes to the quality of the signal, I mean, there's all kinds of like technical technical electronic level issues and amplifiers. You know, these signals are absolutely tiny. We amplify them to, you know, to do anything useful with them and so on. So there's certainly that, but really I think the main sort of thing to understand is that when you put electrode into the cortex, it's like putting a microphone in a hockey stadium, in the middle of it. All these neurons are screaming and shouting that these are the signals, and you are sort of picking these noises. And typically you only hear one or two really close by, but all the others are also, you know, so that's kind of the main source of the noise. But certainly, I mean, you know, I mean, this is like a classic neuroscience story. It's like people do experiment, and then at one day they come to the lab and there is a frequency somewhere which is totally screwing them, and they spend like 3 weeks figuring out that somebody, you know, 2 offices away bought a new coffee machine and so on. So, you know, there's all kinds of fun happening in those types of data, but yeah.
Just wondering if it could be the actual frequency of the pulses would actually, you know, communicate the data in a better way. You know, have you experimented with the frequency? Changing it?
The frequency of like stimulation. Oh, there was a huge amount of like people are playing around with that. And yeah, for sure. But yeah, in this case, right? Like so today actually I didn't tell you. We look at that as well. We have other projects, but today actually I haven't told you about the variety at all. Like how do we actually use that to stimulate the cortex? Today I was only talking about essentially reading, and based on reading from the cortex, even figuring out these baseline representations that we then can use in these other projects to stimulate. So,
yeah, thanks a lot. Very exciting, and everybody was really.
Yeah, thank you very much. Every presentation was very cool. But everywhere, like the issue was really about hiring the people, the team, and like, I mean, I'm literally in the process of probably today or tomorrow offering a first position, but like so much time it took to do so, and like I didn't really have anybody to support me in that, apart from UK, so thanks for that. But any advice, because like you can go as far to like really, you know, have a feeling about the person. Like I contacted somebody from a university like for a reference, but you know, you can go as far in like 2 interviews or something. I did like a fake second round interview to like, you know, just ask some more questions, but in the end, I find it very difficult to decide, to be honest. So any practical advice how to go?
That's a very good question, but I wish I had a good answer, but it is a bit of a, I think, black art, and it you know, involves a lot of like, let's just face it, you know, you can never like perfectly judge the people. I said a lot of words and said nothing, and I think I'll leave it there. I don't really have a good advice. Like it's, you know, you collect as much information as you can, and then based on that, you have to make a call. I don't know. I never came up with any huge human insights on that, like or some rules of thumb or anything like that. Sorry.
That was really cool, cool talk you gave, and I have a question still, like about the visual prosthetics. So can I imagine it somehow as a prosthetic retina, or what I, as a naive person, would imagine is that we know maybe more about what the retina sends than what it's in the visual cortex, but maybe I'm wrong.
No, that's super, like, very good question, and I, you know, again, for time and so on, I ignored a lot of it. So, in fact, people are trying to do also retinal stimulation. In fact, that's kind of the first thing they are trying to do. The issue is that, in fact, more than like half of the diseases which we have are like unsolvable in retina because it's either too damaged or the eye is completely gone and so on. And even this is something quite new to me. I didn't realize that, but we are like writing a grant with some other colleagues, and they really they kind of taught me another perspective on it, which is rather interesting. Is that when you target the retina, you typically target some very specific disease, and those populations are becoming like smaller, 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 and then you find out that it's economically like not viable to basically to make all those devices which are super expensive for that small population. And so in some way actually going to V1 where you can
sort of solve all the problems or all the diseases in some way with one device is actually potentially going to end up maybe the solution also for economic reasons. But okay. But the general answer is, yeah, people are definitely, in fact, most of the, like if I would say that, I would say 80% of effort so far, since like people started to do that, went into retina, and now it's slowly shifting to primary visual cortex.
Super cool, thanks. Makes sense.
Yeah, okay. Thanks a lot.
Okay, so thank you very much to all the speakers. Thank you very much for all of you coming. And now we have the time for lunch and for posters. So that's in the, or where is the lunch? It's in the front or is it downstairs? So where is it? Anyone will tell me? From the back? Yeah, so it's in the same place where the coffee break was. So enjoy the lunch, enjoy the posters. Unfortunately, I need to run for a meeting, so I will not walk around the posters. But if you have any questions, of course, keep in touch with us. So for Primus, it's Roman Hošek sitting back there, and for ERC, it was Veronika Sirovatková, and I was looking if she's still there. She's not, but you've seen her before, so be in contact with us if need be. Okay, so thank you again and enjoy the rest of the day.